is the gap between the knowledge organizations and the NGOs and the communities in order to strengthen जो आत्मनिर्भर भारत की जो टेक्नोलॉजी ड्रिवन सिस्टम और जो सोशल इंफ्रास्ट्रक्चर की पार्ट है उसी को हम सशक्त करने चाह रहे हैं। और ये हमारे ऑब्जेक्टिव्स है। ये आपके साथ में पिछले 3-4 दिन से ये शेयर कर रहा हूँ। तो आपको अभी तक पता चल गया कि हम इसी के तहत एक ऐसे प्लेटफॉर्म लाने चाह रहे हैं कि जहां खाली एक डायरेक्शन से बात ना हो, दोनों डायरेक्शन से बात हो, और इसको एक हम क्रॉस ब्रिज कोलैबोरेशंस के प्लेटफॉर्म बनाए, जिसके तहत हम जो फ्यूचर में जो सीड की तहत हमने जो प्रोजेक्ट सपोर्ट करेंगे, ये फील्ड की जो प्रॉब्लम है उससे निकल के आए और नॉलेज ऑर्गेनाइजेशंस जो उनकी जो टेक्नोलॉजी डेवलपमेंट प्रोसेस भी उसी की रिस्पॉन्स में कम्युनिटी के साथ मिलके हो। तो इसी मकसद में हमने एग्रीकल्चर एंड अलाइड सेक्टर्स कुछ 3 वीक की ये वेब क्लिनिक चला रहे हैं, जो कि हर हफ्ते 2 दिन हम ले रहे हैं। जो पहला दिन STI फॉर सोसाइटी, कल जैसे आपने सुना, जहां knowledge organizations have spoken about their technologies which can be taken to the the field, and आज जो है सोशली रेलेवेंट STI, जो हमारे प्रॉब्लम्स के लिए जो साइंस टेक्नोलॉजी इनोवेशन की जो जरूरत है उसकी बात करेंगे। जो नॉन गवर्नमेंटल ऑर्गेनाइजेशंस और सोसाइटल ऑर्गेनाइजेशंस में जुड़े हुए जो लोग, उनकी जो एक्सपीरियंस है, उनकी जो उपलब्धि है उसकी ऊपर। और इसमें जैसे आत्मनिर्भर भारत की 3 अब सस्टेनेबल डेवलपमेंट और सतत विकास की ओर से आप देखेंगे, जो इनकी जो 3 द पॉइंट्स और एंगल्स है, जो सोसाइटल, एक इकोनॉमी है और एक पर्यावरण और एनवायरमेंटल है। एग्रीकल्चर की पॉइंट ऑफ व्यू से जो सोसाइटल और इकोनॉमी, ये कन्वर्शंस में एग्रीकल्चर में जो पोस्ट हार्वेस्ट टेक्नोलॉजी की बहुत बड़ा भूमिका है, और आत्मनिर्भर भारत में भी उसको काफी महत्व दिया गया है। तो ये हम ये इसी कोशिश में आज की जो हम सेशंस और ये जो डिस्कशंस हम आगे लेना चाहता है, वो है जो पोस्ट हार्वेस्ट टेक्नोलॉजीज की जो जरूरत नॉलेज पॉइंट ऑफ व्यू, जो रिसर्च एंड डेवलपमेंट में जो टेक्नोलॉजी एनजीओस के पास है उसको कैसे इंप्रूव किया जा सकता है, और उसकी कैपेसिटी से कम्युनिटी को कैसे दिया जा सकता है। इसी सब एक्सपीरियंस की और ऊपर हम आज के सेशंस का आगे लेना चाहते हैं। हर सेशंस होने के बाद हम कोशिश यही कर रहे हैं कि इससे जो सिस्टम लेवल पे क्या अपॉर्चुनिटी निकल के आ रहे हैं उसको कैप्चर करने के बाद आप लोगों के सामने लाने का ये जो पिछले वीक का जो पहला हमारे वेब क्लिनिक का जो पहला दिन था, उसमें एग्रीकल्चर प्रोडक्शन इनोवेशन सिस्टम्स में जो हमने कैप्चर किया था, ये आपके सामने है। उसके जो अगले दिन जहां एनजीओस एंड कम्युनिटी ऑर्गेनाइजेशंस जो बताया था कि जो नॉलेज ऑर्गेनाइजेशन के साथ क्या कोलैबोरेशन हो सकता है, इसमें आप देखिए बहुत सारे जो आइडिया, जो नए जो चिंतन और नए जो उपाय जो निकल के आया, लैंड टू लैब एक प्रोग्राम की हम बात किए थे, जो इम्प्रूवमेंट लोकली प्रोड्यूस टेक्नोलॉजी जो एनजीओस के पास है, उनको कैसे नॉलेज ऑर्गेनाइजेशन के साथ इम्प्रूव किया जाए। तो ये जो डिस्कशंस के जो मेन मुद्दे हम कोशिश कर रहे हैं कि आप कैप्चर करके आपसे शेयर करने के लिए, ये जो ISTI पोर्टल जो विज्ञान प्रसार जिसको जो चलाते हैं, उसमें भी हम डालेंगे, जिससे आप अपना विचार दे सकते हो। तो इससे एक डायनामिक प्लेटफॉर्म जो हो, जिसमें हम हमारे टेक्नोलॉजी डेवलपमेंट को हमारे जो चाहत और रिक्वायरमेंट के मुताबिक हम करना चाहते हैं। तो कल जो पहला सेकेंड वीक का जो पहला दिन था इस वेब क्लिनिक में, जिसमें पोस्ट हार्वेस्ट टेक्नोलॉजीज के ऊपर नॉलेज ऑर्गेनाइजेशन पे बोला था, उसमें जो अपॉर्चुनिटी हमें दिखाई दिया कि हमने बात हुआ कि जो नए और इमर्जिंग जो टेक्नोलॉजीज है उसको सारे देश में कैसे एनजीओ कोलैबोरेशन के तहत हम लिया जा सकते हैं, जिसमें बायो फोर्टिफिकेशन ऑफ फूड की बात हुआ था, जिसमें CFTRI के हमारे एक्सपर्ट्स बताए थे, जूट एंड एलाइड फाइबर्स, जिसकी जो ऑर्गेनाइजेशन है उनकी डायरेक्टर डॉक्टर कर ने बताया था कि हमारे बहुत सारी ये जूट एलाइड फाइबर्स की चीजों को एक्सपोर्ट करने का एक बहुत बड़ा मौका और अपॉर्चुनिटी है, जिसको कैसे हम ये टेक्नोलॉजी के वो लोग तैयार है कि जो देश की कोने जो डिफरेंट डिफरेंट क्षेत्र के एनजीओ के साथ मिलके ये कम्युनिटी के अंदर के कैसे ये जो नए अपॉर्चुनिटी की कैपेबिलिटी हम तैयार कर सकते, इसमें एक नए सशक्तिकरण की दिशा, जिससे उनको हायर वैल्यू चेन में हम उनकी एक्टिविटी ला सकते, जो कि आत्मनिर्भर भारत की एक एक जो प्रधान मुद्दा है। और एग्रो क्लिनिक्स की बात हुआ था, एक बात हुआ था कि जो रिसर्च ऑर्गेनाइजेशन है वो कैसे जरूरत के मुताबिक एनजीओस और कम्युनिटी ऑर्गेनाइजेशंस के साथ मिलकर कॉन्ट्रैक्ट रिसर्च कर सकते हैं, जो लैंड टू लैब ये सोच से, जैसे उसमें पोस्ट हार्वेस्ट टेक्नोलॉजी की जो डिफरेंट डिफरेंट टेक्नोलॉजी है उसके ऊपर। एक आईआईटी मुंबई से एक जो प्रोफेसर ने प्रेजेंट किया था ई यंत्रा, और वो ई यंत्रा जो कि रोबोटिक्स के बहुत ही बेसिक रोबोटिक्स की जो इस्तेमाल हो सकता है हमारे छोटे और मार्जिनल फार्मर्स के लिए, जो कि एग्रीकल्चर यूनिवर्सिटी के साथ एक कोलैबोरेटिव मोड पे हो सकता है। ऐसे माइक्रो एंटरप्रेन्योरशिप जनरेट किया जा सकता है, जो हमारे जो ट्रेडिशनल टेक्नोलॉजी है उसको इंप्रूव करके नए टेक्नोलॉजी लेने के, जैसे गुड़ तैयारी में एग्रीबॉट हम ले आ सकते हैं, जो डिफरेंट पोस्ट हार्वेस्टिंग टेक्नोलॉजीज के तहत। सिमिलरली बात हुआ था कि जो ये अभी कोविड के सिचुएशंस में बहुत हमारे दुनिया अभी वर्चुअल आ गया, तो इससे कैसे वर्चुअल टेक्नोलॉजी इंक्यूबेशंस, ये सब नए टेक्नोलॉजी के इंक्यूबेशंस कैसे कम्युनिटी के अंदर एनजीओ कोलैबोरेशंस में हम कर सकते हैं। तो ये जो कल की जो डिस्कशंस हुआ था उसकी जो उससे जो निकला हुआ है अपॉर्चुनिटीज, वो हमने कोशिश किया कि आपके सामने लाने के लिए। ये हम अपना पोर्टल में डालेंगे, और हमें आपके पास अनुरोध है कि इसके ऊपर आपकी जो विचार है, आपकी टिप्पणी है, आप आईएसटीआई पोर्टल में दें, सो दैट हम उससे हमारे जो प्रोग्राम और हमारे जो फ्यूचर डेवलपमेंट ये रास्ता हमें मिले। ये है, पहले भी हमने बताया था और फिर जो नए लोग आए इनको हम यही बताना चाहते हैं कि यहाँ जो आईएसटीआई पोर्टल की एक कोने में ये डाला हुआ है, जहाँ साइंस सोसाइटी सेतु पर आत्मनिर्भर भारत के लिए आप रजिस्टर करते हैं, उसकी क्लिक करने के बाद आप देखेंगे जहाँ अपनी प्रॉब्लम्स, अपनी आइडिया आप डाल सकते हो। हम कोशिश करेंगे कि आज भी जो आपने क्वेश्चंस करते हैं वो इसी पोर्टल के तहत इसकी उत्तर आपके पास पहुंचाने के लिए। हमें उम्मीद है हम जो ये जो प्रचेष्टा, जो कोशिशें हमने शुरू की है, आप इसमें शामिल होंगे, खाली आज या ये वेब क्लिनिक्स के तहत नहीं, भविष्य में हम इसी जो प्लेटफॉर्म के तहत हम कोशिश करेंगे ये जो सिस्टमिक गैप है इसको कैसे हम कम कर सकते हैं, और आत्म निर्भर भारत के लिए जो आत्मविश्वास और आत्मसम्मान, ये हम कम्युनिटी के साथ काम करके जो इमर्जिंग टेक्नोलॉजी, जो उभरे हुए तकनीकी की जो फल है, ये कम्युनिटी के अंदर हम जल्दी ले जा सकते हैं, सो दैट एक लिव फ्रॉम एक मैकेनिज्म तैयार कर सकते हैं और उनको जो वैल्यू चेन के हायर एंड पे ले जा सकते हैं। ये हमारे उम्मीद है, इसमें हम सभी इकट्ठे काम करेंगे तभी ये संभव है, और हम उम्मीद करेंगे कि आप हमारे साथ जुड़े रहेंगे। धन्यवाद। थैंक यू वेरी मच। सो आई थिंक वी प्रोग्राम Just I will just stop my sharing. And to start today's this discussion sessions, I will request Mr. Kiruva from Barefoot College, Rajasthan, which is a one of the course groups from CDDST, to share with you the IoT-based controller for solar dryer, what they have developed and how they have developed the capacity of the community through that, and what are the research opportunities in that. Mr. Kiruva, please. Thank you.
Thank you, Dr. Datta, for your warm welcome, and a very good afternoon to everyone. I hope everyone can see me.
Yes, everyone can see.
Yes.
Oh, thank you. As Barefoot College is a member of the Pro Support Group, we are very happy to be here to present our work to all other CSGs and knowledge institutions. Next slide. Barefoot College, also known as Social Work and Research Center, was founded by Sri Bankar Roy in the village of Silora in Rajasthan. We started our work in 1972 by covering villages in and around Silora in Ajmer district. To give you a quick brief about what work we do, it would be perfect to say that we are in the business of empowerment. When I say empowerment, what I mean is that empowerment by providing access to energy, education, clean drinking water, livelihood, and advocacy. Under solar, we run a 6-month residential training program for illiterate and semi-illiterate women from rural villages. You have to understand that if you have been a formally educated individual, you will not be selected for this program. The program is only for those who have never been to a formal education, to provide them an opportunity to learn and fabricate solar panels and homemaking. Education. So under education, we also run a similar program for children who are left behind from the formal system. We run night school programs for the children for whom it's not possible to go to a day school, either because of financial reasons or they have to work in the farm in the daytime. So these schools run from 6 to 9 p.m. in the evening, where these children come and learn. And we have been able to digitize these schools with the help of innovative products like solar projectors, with the help of DSTC division. So water has been our biggest partner since we started our work 14 years back. And till date, we have built more than 1,500 rainwater harvesting structures all across India. Apart from that, we are also working on different water filtration systems such as reverse osmosis and capacity of deionization. As most of you know, and most of you would have in your home an aquifer or a aquaguard. But the biggest problem with the reverse osmosis is that the water wastage. So we, along with International Center for Clean Water, a research institute under IIT Madras, are working on new and efficient water filtration systems. Under livelihood, we have been working under the brand Pilonia Handicraft for the past decade, where we empower local women from Jodhpur and Badma districts of Rajasthan to sell their handcrafted clothing materials all over the world. And last but not least, empowerment through advocacy. We are very vocal about advocacy wherever we work, and we were the front runners in helping Right to Information RTI Act legalized in 2005 along with the organization and cases. So as we move on to slide number 3, you can see our work in numbers. See, we work in 17 states in India, both directly and through partner organizations, where we have trained 717 solar mamas. These are women who had no formal education, who had left formal education, who after the training program were able to install 30,000 plus homemaking systems across India. We have also constructed 1,500 rainwater harvesting structures all across India. And if you look at our international presence, we have also trained ladies from 96 countries across the world. So these candidates have come to Pilonia, stayed in Pilonia for 6 months. After their training program, after learning the solar landing and the solar homemaking system, they were able to go back to their countries and electrify their villages. By doing that, we were able to save 5 million liters of kerosene from being used in the household for light and as a fuel. Slide number 4. As today's discussion, the previous one. As today's discussion is about post-harvest technology, we would like to brief you about the project we have been working on, IoT-based smart controller. As our Secretary, Professor Ashutosh Sharma rightfully mentioned in his inauguration speech a week back, there are many forms of solar dryers and they are commonly found everywhere. They are ubiquitous. So when we got the request from the communities for a solar dryer, we had to be very sure that we are not reinventing the wheel again. On slide number 5, you can see that there are many various versions of solar dryer. In the world of convection, there are active convection solar dryers, passive convection solar dryers, with mixed and hybrid as well. There are greenhouse solar dryers and chamber type solar dryers. So it is a huge area to cover. Slide number 6. So we did a baseline survey to better understand what exactly are the challenges in the current market, and we found interesting answers. Dryers that were made for leafy vegetables are used for fruit produce, and the same were used for meat products in certain cases as well. No clear instructions were followed in the maintaining or the temperature that needs to be maintained in the drying chamber. So even though the market was filled with many dryers, the root cause of the problem was not clearly addressed. Most of the dryers were working on substandard efficiency. Next slide. That's why we worked on a smart controller which acts as a brain which can be retrofitted to any dryer available in the market irrespective of their size or shape. The controller will be able to change its environment based on the need. It will be able to measure the temperature of the drying chamber as well as the ambient temperature. So it will be able to control the humidity and the air velocity. Next slide. With the help of the controller, the farmer will be able to control the drying process with a high degree of precision. As we finalized the project, we started to build the product. As you can see here, the PCB of the smart controller was produced in Polonia. I have to specially thank DSP Feed Division, Dr. Datta Sunil Agarwal, Anuradha ma'am, and its expert committee in helping us to set up a fabrication lab in Polonia, through which we were able to make a PCB right here. This shows us how self-reliant we are. Next slide. These are images of the lab machinery that we have in Polonia, a 5-axis milling machine capable of printing double-sided PCBs, laser engravers and 3D printers, so that any idea we have can be converted to real tangible products in real time to test it in the field. Next slide. As you can see, we made the first prototype with the help of the Fab Lab with all the sufficient sensors to track all the variables both inside and outside the drying chamber. Next slide. We have also prefed all the information that's required for the drying process in the controller. As you can see in the chart on the right side, an onion might need 55 degrees Celsius for 48 hours. On the other hand, a potato might need 75 degrees Celsius, which is a stark difference. So the final product should also not exceed the certain moisture content, so that the final product would be in the right condition to be sold for the premium quality, thus increase the farmer's income. The farmer would just need to select the right option according to his produce, and the rest of the job is done by the smart controller. Next slide. We have also added the IoT capability for the device so that any required maintenance can be done remotely. We will be able to track the operational efficiency of the system and the device goes to scale. Let's say if a vendor needs to dry his produce at a large scale, all he needs to do is just to press a button in the controller and n number of solar drying units can be controlled in that one manner. Next slide. These are some of the pictures of the smart controller being tested with varied designs of dryers such as a tunnel dryer on the left or a chamber-based dryer on the right. In a controlled environment where we have tested for the past 6 months, we have been able to see the dryer efficiency increase by 25% just by using the smart controller. Next slide. So when I say 25%, it means that the time needed to produce has gone down sufficiently and the quality of the product is consistent every time, thus giving opportunity for the farmer to earn more for the same produce in the same dryer without investing much. And very soon we will be testing this solution out in the field in and around Rajasthan for real world metrics. When it comes to challenges, I have some of the points to discuss here. Having access to certain network protocol is very crucial for an IoT device to communicate. And in rural areas where we work mostly, network connectivity is very hard to come by. Certain network protocols such as low power wide area network or LoRaWAN might be able to overcome these shortcomings of GSM and LTE technology that we currently use. So getting access to these technologies as a known NGO, we find it difficult. It's difficult to use it in the products such as these. So we expect the knowledge institutions and the other organizations to be able to share some certain suitable substitutes for these network protocols and an option to work forward in the IoT domain. Next. Again, I would like to thank DST and other agencies in setting up this web clinic where we are able to share our work and also to learn from each other. And for the viewers, if anybody wants to get in touch with us, you can write to us at contact@greatbasketball.com. Thank you.
Thank you, Mr. Kirva. I think it's a very objective and such a net way to present your this work, and this shows the the technology development dissemination is it's not an one-way process. Like it doesn't go on always from the knowledge organizations to the NGOs or the communities. There is a local level requirement has led to the not only development of a technology, but improving the efficiency of the technology also. This is an example of that, and you have very well brought it out that what are the research issues also you're looking forward, and also thought that as in the individual NGOs, that what is your limitations and how these collaborations with the knowledge organizations can obviate that. Thank you very much. Please be with us because I'm sure that then after this the interesting presentations, there will be questions, and please be with us so that we can take it and you can provide the right answer to the the question makers. And so we'll go to the next the next discussions is from Mrs. Ujjwala Goswami from Climbers Engineers, Pune. So this is regarding the manufacturing of the rice dehusking. And like this is one of the technology which is among of the the whole support groups, the NGO, and how it has already been taken in the upscale, because we have seen that this is a problem of the manufacturing and there is a lack of the capacity in our this the system, which is to our Atma Nirbhar Bharat. So I will request Mr. Gosabi to start a discussion.
Hello.
Yes, madam.
Namaskar.
We can hear you.
Am I audible to you?
Yes, madam. You are
audible. Good afternoon, all the dignitaries. I'm Ujjwala Gosavi. I am presenting the journey of my rice dehusking machine, which is the technology of the Vigyan Ashram, and my company has designed, developed, and commercialized this machine to the and go to the customer. Next slide. Before that, first of all, we have to see what is the difference between brown rice and white rice. In the process of brown rice, we only peel out the cover of the rice, and in the process of white rice, there are 4 layers on the white rice that we removed, so we get the white rice. In the process of rice dehusking machine, we are only peel out the cover of the rice. Next. Then what are the methods of production of the brown rice? There are actually traditionally it is a hand pounding method. And secondly, there are no as such machine available in the market to produce the brown rice in a high production rate. Whatever mills are there, the mills rice is fed in the rollers, and first stage roller and second stage pass. We will get the first pass rice and second pass rice. In that first pass and second pass, again the bran layer of the rice is removed. Next. Limitations of hand pounding rice. As per hand pounding word shows that this is always done by the woman. It is a physical and tedious work. it requires whatever production by this method is very much less, as it is depends on the labor. Again, the breakage of rice is more, 95 to 98% breakage is there, and so farmer doesn't get the rate for that one. Again, the whatever process is this, in this process, the broken rice, we get the broken rice, then powder and husk. So powder form, in this powder form is not useful for the farmers. Limitations of the milling. In the mills, already they have taken out the bran layer of the rice. So this is not the authentic brown rice. Only husk is not removed from there, and in this process we get the rice, broken rice, bran powder, and husk. And again, in this process also, whatever production, it is a 50%. Next. Rice dehusking technology. This is the rice dehusking technology under the seed project. Vigyan Ashram has developed this technology. They have make a prototype for that one. This picture shows the prototype of the Vigyan Ashram. Then in this prototype, only technology, whatever they have decided is that technology means what type of motor it will require, what will be the rating of that motor, what should be the speed. As it is a cold milling method, we do not want to increase the temperature of rice. Next. This is the journey of my company. After the technical tie-up, we have designed this machine. It has gone so many stages from design, development, then first piece, then launching of first product. I have given the first product to the farmer in December 2018. After 2018, I have sell out 30 machines in the market. I have make a ICR certification for this machine, and now this machine is eligible for the subsidy in the market. Also, this machine has got an award of MCCI. Next. Manufacturing of our machine. This manufacturing has two stages. First of all, we have to understand the technology. To design to understand this technology and to give to the customer, we have to analyze it. We have to analyze it, and what the processes, what material selection, how it is to be done. All these things we have to do. What we have done, the difference between, if you see, this is the right hand side is a design of our machines on the computer, and this is the actual machine in the next photograph. In this machine, we have to design the hopper size. First of all, for the capacity hopper size, we have designed. Then for the hopper, we have designed a control, feed control valve we have designed. Secondly, in the Vigyan Ashram machine, the shaft is tools are attached to the shaft and they are welded. But it should not happen in my machine, because customer has to change this tool after 5 tons of rice. So tool should be exchangeable. That's why what we have done, we have designed it such that it is easily exchanged by the customer only. Next, second thing, the duct is designed. If you see, this is the prototype of Vigyan Ashram, and this is my machine, first machine, climber engineers. Secondly, tool change should be easily, and changing of tool is done by the Pokayoka method, so that farmers doesn't have any type of forward, can be fix the tool in the groove as it is. Chassis are such designed that dimensional accuracy should be there. It can be manufactured easily, and it has less vibration. It should have less vibration for that one. Again, all the spare parts here we have provided are exchangeable. They can be replaced easily. Again, MCB we have provided for that one by considering the electricity fluctuations in the villages. This machine, whatever machine we have designed, is a balance for dynamic loads so that the vibrations, its noise problems can be handled. Next. These are the technical specifications of our machines. Production rate is 15 to 20 kg. Its loading capacity, hopper size is 20 kg. Weight of machine is 120 kg only. Power specifications 1 HP. It's a single phase machine. Maintenance, it doesn't have so much maintenance. Only the customer has to check its gearbox oil after every 3 months. And again, customer has to change the tool, de-husking tool, after 5 turns of rides de-husking. Next. I have shown economic calculations on this. If we consider that customer is as just like the company, if customer has done 10 hours machine 10 hours working of a machine is 10 hours, then he, as per the record 15 hours, if you consider the rate of the machine is 15 kg, then customer can, in the 10 hours, customer can husk its rice as a 150 kg. And by that calculations, I have done that. And after this calculation, if we take out all the expenses and all these things, the customer can get 1,000 rupees per day as his income. Next. Now, for whom this machine has made? This machine is made for the upliftment of the self-help groups, small rural businesses, women entrepreneurs, NGOs. The farmers can also use this machine as their parallel business or their value addition business. Farmers group can do that one, or farmers company also can take this machine as a business. Next. After making these machines, I have got a Marathi Entrepreneur Network Forum Award for this machine in the June 2019. Next. This machine also has got as an innovative product. This machine has got an award, Rababai Joshi Award for the from Maratha Chamber of Commerce in December 2019. Certification. This machine has been certified by the ICAR's Kontur, and just now this machine is eligible for the subsidy to the farmers. Now these are the photographs of the customers to which myself and Mr. Anil Gosavi is giving the training. Secondly, while doing this machine, we have some challenges. We have some challenges because farmers have, after seeing these machines, farmers are asking us to give the de-husking of the farmers have inspired us to give the de-husking of gehu, oats, millets, and all these things. So we have to do some attachment or another something which we can provide with this machine as a replacement for this one. Also, we want to increase of the capacity of this machine by using the rollers, because some farmers have that much of demand that increase the capacity of machine, and this rollers, whatever disc we have taken, they have its own limitations. We cannot increase the rate of production from this. So we want to go to the rollers for the designing and increase the capacity. Again, with the as farmers have seen the machine in our company, they are asking us for the paddy thresher, a small paddy thresher, because there are thresher in the market. So many threshers are there, but in just like the small farmers, marginal farmers, they don't require that much of higher capacity thresher. So they are asking us paddy thresher. And next challenge is that screening of the rice. This is a big challenge for us, because screening and packing for small packing is for to packing machines to the farmers. Screening is a big challenge also for us, because that whatever rice come from this machine is a have different size, because after polishing the total white rice has a grain size is a similar, but in this case in this machine the grain size is different for each and every particle. So the screening is the most challenging job for us also. And the next one is packaging. Farmers want the packaging. It should be in a 1 to 2 kg, because life cycle of this of this rice is very small. So they want small packaging. Next. Support. We want the support to make the machine available in the different parts of the countries, because there are whatever rice farmers are there, they are in a various part of India, and they are at a very distance. So I want support from the DST that making this machine available in the different parts of the country. Again, I want to scale up my production capacity, because farmers are very keen to take this machine. So I want the equity investors. Again, making the product available in government India's livelihood program. Because, also, this is also support I want, as brown rice is a very healthy rice and a good for the health of. So there are many programs for the children also, for the ladies also, and for the women entrepreneurs, for the SC/ST community, and all this. So I want this my product should be available in the government's livelihood programs. Next. Again, thank you. This is my address and all these things, my details are there. And I'm very much thankful for the DST for giving me the opportunity to present my product, rice dressing machine to you. Thanks a lot.
Thank you, and Dhanyavad, Mrs. Kosabi. I think when I was listening to your presentations, मुझे यही लग रहा था कि आत्मविश्वास से आत्मनिर्भरता का जो एग्जाम्पल है आपकी, ये जो कंपनी जो हमारे विज्ञान आश्रम की सहायता से शुरू हुआ है, is an example that how really the आत्मनिर्भरता at a local level, according to the local requirement, can be brought to this, to this type of a company what you have started. And actually, you have brought it out also that it is not only there is a systemic gap between the knowledge, the transfer in both way, but also once we develop the local capacity, then there is a challenge that how you can upscale that capacity. That what you have told that and I think in that context, this is a good case that where we can, the DST can start talking to the MSME ministry and can showcase that this is a case which needs an MSME ministry support in order to upscale. That what you have said, like how to upscale that. And also we will talk to the MORDs, that the NRLM, like this is a good example how it can go into the NRLM for creating the local high technology, the post-harvest capacity, which is a focus on Atma Nirbhar Bharat. And also for that, what you were saying is the technological challenge is downscaling at a feasible the scale, and so that needs also creates an opportunity of collaborations with the knowledge organizations at your end. And so I really thank you for giving this a wonderful example, and which shows also the strength of Vigyan Ashram of creating the local level, the capacity for this type of manufacturing, which improves the efficiency of the livelihood system at local. Thank you again. And then I invite Dr. Nigam Shukla, who is a chief scientist and head of the KVK Krishi Vigyan Kendra, Bhavnagar, to discuss about the processing of the farm produce and the technological challenges. Dr. Shukla, please.
Hello. Hello.
Yes, Dr. Shukla. Yeah. Yeah. Can you put your we are audible but very low. Can you put your video on, please?
Yeah, it's on, sir.
अच्छा आपको दिखाई नहीं दे रहे. Anyway, आपका volume थोड़ा बढ़ा सकते हैं, because then we can hear you.
Certainly. Hello.
Yeah, अभी सुनाई दे रहे. This is nice. This is good. This is good.
Is the video?
Thank you. Yeah, thank you, Dr. Shukla.
Am I
Video
visible?
is not. No, you are not visible, Dr. Shukla. You are not visible.
So I have tried, but I'm not getting the camera on.
That's fine. That's fine. That's fine. Let's go ahead. We can hear you.
Okay, thank you, and good afternoon, everyone. Thanks for giving me this chance. Actually, I am attending this meeting for the first time. As an extension agency in KVK, we are just extending the recommended technologies, post-harvest technologies to our farmers groups, self-help groups, and we are just trying to uh, disseminate these technologies and techniques just to harvest better and to store it properly. Next, please. Before going to the technologies, first I would like to mention the losses which are caused after harvest. Generally, the loss is a measurable unit, and that is loss of foodstuffs, that both in quantity and quality in terms of actually India is the second largest producer after China. However, we are not able to get the farm produce processed as the developing countries and other developing countries like China's are processing, and that's why in India we account about 600 billion rupees loss in terms of wastage of food material, farm produce, and it is the amount through which we can feed at least 1/3 of the poor population of India. Next, please. Next, please. So, what is the post-harvest technology? Means any technology, any system which encompasses the delivery of a farm produce right from the time and place of harvest to the place of consumption with minimum loss and with maximum efficiency and with maximum return to the farmers or the producers. It's generally a system of conserving, processing, and value adding of farm produce. Next, please. In our Indian condition, why we need post-harvest technologies uh, in recent times? Because as we see our farming condition, there is an urgent need of increasing the land and labor productivity efficiency as well. We are also accounting great huge post harvest losses, and on the other hand we are also facing some poverty and hunger in our country. It is also necessary to maintain and enhance the quality and quantity of the produce. Secondly, the post-harvest technologies have the potential to create the rural industries, and then only we can just stop or can decrease the brain and capital drain from the rural areas to the urban areas. It also provides employment opportunities to the rural people. So the migration to the urban areas may be decreased. Next, please. So this is the complete post-harvest system for agriculture produce, right from harvesting to consumers' satisfaction or consumers' preference. It's a system, and where there we need to apply these technologies and techniques. Next, please. Looking to the system, we can see that the losses occur at many stages, uh, right from harvesting to and disposal of the food material. Uh, Different stages means at the time of threshing, drying, and that is because of improper handling or improper use of the technique. Next, please. So, largely we can divide the post-harvest technologies in two different groups. That is for grains, which include cereals, millets, pulses, oilseeds, and second, fruits and vegetables, which are perishable products. So, when we look for post-harvest technologies of grains, especially, uh, very few uh, and minor technologies or recommendations, if farmer groups follow, we can avoid the losses. That is just harvesting with the proper tools and implements or machineries, drying the seeds or grains at the proper temperature in proper climate, threshing, proper threshing machine or a mechanism should be used. And at the time of storage, we have to store the final farm produce uh, at, in proper packaging as well as at proper site. Next, please. Looking these technologies, there are few technologies I have listed for different stages. Here I have shown that the conventional method of harvesting of many crops, that is through sickle only. It is very much time consuming, labor consuming. It is expensive also, and in uncertain climate, we farmer may account for some loss of farm produce or final product. Instead of this, CIA, Bhopal, and many other agencies have developed so many other harvesting tools. Like we can see here that the combined harvester for a rice, groundnut digger, self-propelled reaper for the crops like sorghum, wheat, and everyone. If the farmer is big and possess large land holding, they can use tractor-mounted reaper also. Next, please. So by using these technologies, here we can see the cotton harvester picking cotton at maturity is very labor intensive operation. And right now, as I am from Gujarat, I know it very well that it is very difficult to get labors for picking cotton. So here we can see that cotton harvester uh, as well as harvester combiner for sorghum and other crops. Next, please. Then comes the threshing. Generally, in our farms, farmers are used to thresh the crop by beating or the manual methods like animal operated implements and through other techniques. But instead of this, here it's a slow process as well as labor consuming and expensive also. And seed damage is much more than that of the recommended new technologies. That these technologies are next, please. Next, please. Mechanical threshing. Uh, we can see here the thresher for cereals, oilseeds, pulses, and millets. It is simply operated at farm site also, and it is very fast, less expensive, and um, the damage of grains is very negligible as compared to the our manual local method. Here we can see the groundnut decorticator that is released by Directorate of Groundnut Research. After threshing for decorticating that groundnut seeds, the machine is used. It is manually operated and it is very easy to operate. Next, please. Winnowing is something is an operation to clean the seeds after threshing. Now, manual winnowing is okay for small scale farmers where the farm produce is not so large and huge. But for huge product, mechanical threshing, mechanical winnowing or cleaning is advisable. That is through sieve cleaning. Next, please. Next, please. Yeah, here we can see mechanical cleaner cum grader that cleans the seeds through scalping. It separates the light, small, and big particles, as well as also remove the high moisture contained particles also. Uh, and spiral separator. Uh, so the spiral separator is also well fit for small farmers and small quantity, and it is used for circular seeds only. Next, please. Drying is generally done under the sunlight, and it is almost done by all the farmers all over. It is okay, but in this technique, temp, temperature must be maintained at below 35 degrees centigrade. The advantage is that it is there is very low investment, hiring 2 to 3 laborers or something like that, and it is easy for small seeds and small quantity of seeds also. Whereas the disadvantages are that it is a very slow process, exposed to the weather vagaries, and temperature and humidity cannot be controlled. So there may be some chances of infection of parasites, predators, or some disease organisms, microorganisms. Next, please. For small quantity, the farmers groups can use a batch dryer also, in which a small quantity of seeds can be dried in batches, and it is very cost effective also, and easy to operate, and humidity and temperature both can be controlled in this device. Next, please. Next, please. Thank you. Now different types of seed and grain processing plants are also available for large scale cleaning, and there are fixed type of plants are also portable type which can be moved from farm to farm, that are also available, and mobile type of plants are also available in market, and now gradually farmers are using it. Next, please. Packaging is also an important criteria for storage of the produce grains and seeds. The different types of bags are available, made up of different material like jute, cotton, plastic, paper, cardboard, polythene. Next, please. But storing the produce. Next, please. Traditionally, farmers use many other conventional technologies like using bamboo and cemented coatis, gunny bags. Now over time, galvanized structures are also available, and at some places, small farmers use the masonry structures also, that we can see here. Next, please. In all these technologies, it is very much necessary to mention that small farmers having small piece of land cannot afford costly technologies. Hence, a group of farmers or a custom hiring center for all these machineries could serve the purpose to use these technologies for a small farmer. Uh, Looking to the second part of post-harvest technologies for reducing losses for fruits and vegetables. In this section, as you all know that the fruits and vegetables are very perishable product, and that's why right from harvesting, its handling at different stages up to the transportation and serving it to consumers plate, it is very much important to take thorough care. Next please. Next please. All these I have mentioned different stages and few of the recommendations which to be kept in mind, right, while taking this operation. Next please. In fruits and vegetables processing, food processing is an important criteria to minimize the loss or wastage of food material, because as I say again and again, it's a perishable product, so it cannot be stored for a longer period. But through processing we can add some value, that is value addition, making jam, jelly, or squash or something like that is the packed product for its further use.
Dr.
Next please.
Shukla, could you please expedite like in the 5 minutes, please?
Yes, certainly. Next please. Next please. So these are the different tools used at farm level, and we are disseminating these technologies to the farmers. That is windy plucker, fruit pluckers, and all that, which fastens the operations as well as avoids injury to the fruits, as well as it reduces drudgery for the farm laborers. Next, please. Next, please. These are the different types of gradings, manual grading versus we can see here the different types of graders are available in market for different types of fruits. Next please. Next please. These are the conventional and traditional packaging and transportation methods used all around, but instead of this, next please, this type of containers which avoids injury, and many experiments are done by SAUs, state agriculture universities, and it is successful to pack it with LDP bags to store it for a longer time. Next please. Next please. Vacuum packing and all are, these all are the other options of packaging. Next please. Next please. Processing. Next please. So these are the techniques through which we can minimize the loss, and these are the technologies. So the constraints which we generally see in field among the farmers to adopt these technologies are the small holding of the farmers, so that they cannot afford the high costly machineries, as well as decrease in production due to natural calamities sometimes reduces the farm output, and that is also a big issue. A lack of storage and processing facility at village level. So we all can see all these machineries and infrastructure at urban level, but in rural area the facilities are very less. High cost of labor for operating these machines, lack of remunerative policies like uh, premium prices are not available in market for the processed food in local markets, lack of transportation facilities like for transporting perishable goods, cold chain is very much necessary, and at farm level it is at rural level it is not available easily. So all these are the constraints in adoption of this post harvest technologies. However, being an extension worker, we have seen that it could be possible. It can be possible if we can form such a self-help groups and FPOs, especially farmer producer organizations, which procure the farm produce at village level and can process after the products after harvesting, and can store it or can market it and can transport it in a large amount. Or at village level, we can establish some custom hiring centers for these machineries and technologies, where a small farmer can also hire a required equipment or instrument for farm operation and can use these technologies. Thank you very much. Thanks to the DST personnel for giving me this opportunity to contribute my views. Thank you.
Thank you, Dr. Shukla. I think with that we end our the lead talk sessions, and I request my colleague Dr. Kinkini Dasgupta Misra to take over the next sessions, and which will be the panel discussions. Dr. Kinkini, please.
Yeah, thank you, Dr. Datta. From the key presentation, it reflects that the effective post-harvest management allows not only the minimization of losses, but also increases the value of the marketable agricultural products. So I think it is essential that improve post-harvest handling and processing to ensure high-quality produce to reach the market, which can be strengthened with the application of emerging technologies. And it was also brought up that the efforts made in developing the local capacity and how to upscale the capacity for self-reliance. Now in the panel discussion, we'll be discussing more technological interventions in farm livelihood. We have 4 presenters today, and the first presentation will be made by Dr. Nobonita Dotto Bordoloi, Cultivation and Value Addition of Pineapple for Economic Upliftment. I invite Dr. Nondita Bordoloi.
Good afternoon, everybody. Can you hear?
Yes, we can hear you.
Yeah.
Yes, we can hear you. You please put your camera on.
Yeah. Okay.
Yes, fine. No, we can't still see you. We cannot.
Can you see me?
No, not yet. Doesn't matter. You proceed. You carry on with your presentation.
Okay. Good afternoon, everybody. I am Dr. Nobonita Dotto Bordoloi from Purvottar Development Society. At the very outset, I would like to offer my sincere thanks to DST, especially Seed Division and other division of the DST for organizing such a webinar, and thanks also for giving me the opportunity to present here. So anyway, my presentation on cultivation and value addition of pineapple for economic upliftment. Actually, this is a work for the project I have completed recently by the Seed Division of DST, Government of India. And I would also like to inform you that I am associated with DST from since 2004, when I was selected as in the Women Scientist Scholarship Scheme, WOSB, in the first batch. And from this, I have worked on this line, Science and Society for upliftment of rural people, mainly rural women. So next, please. So the main objective is the production of quality plantlets of pineapple through in vitro auxiliary bud culture and in vivo leaf culture method. We all know that the pineapple in northeastern region is famous for pineapple because it is a very popular fruit in the region, and this is also because the climate of the region and soil type. So we have I have chosen for in vitro production of pineapple because in natural condition the vegetative propagation is very low, but in vitro micropropagation it takes enough planting materials, and also it is the equal size, and they are also disease free, and large plantlets at a time. So the next objective is to establishment of demonstration plots as a model for transfer of technology from lab to land by involving women self-help group. In this regard, in the lab to land process, I involved some women self-help group in and around Guwahati. Generally, I have selected 5 women group from with 10 members of each group, and engage themselves for rearing of tissue culture pineapple plants. Then third one is popularization of cultivation practices of pineapple as intercrop in banana orchard by adopting relevant agrotechnology, on-farm demonstration and training. In this regard, I also informed that pineapple is a one-year crop only, and therefore to benefit for the farmer, it is advised to intercrop in banana orchard or in wheat, turmeric, ginger, etc., so that they are benefited by economically. Then fourth one is development of marketing channel for the women self-help group to sell their products such as planting
I'm sorry, madam. I'm sorry. I have to intervene, madam.
Yeah.
Please, this is not a like your DST project presentation. Here we are discussing about the system requirement. Please come while implementing the project, what the system gap and how you have developed the communities, the capability, and what are the research issues you. So this is not a DST's project presentations, because many people get this is not the forum for that. Please.
Yeah, and actually the last objective is that how we value-added, we say the pineapple is the value-added into value-added products. So next, please. Next, please. Next. This I have already told the target area unemployed. Next, please. Next, please. This is some photographs of in vitro micropropagation of pineapple. Then next one, please. This is the training facility. So we have trained how to rear the tissue culture pineapple plants, and also for value-added products. They generally commonly value-added products. All the common products are jam, jelly, sherbet, then as a fresh fruit, etc. But I have concentrated on the canned food, where the freshness of the fruits is more. They are for more than 1 year at least. Next, please. This is the different stages of preparation of pineapple for preservation in can. So this is we have trained these women self-help groups for these different stages of pineapple. Then cutting, then washing, then how they seal the containers, what are the sterilization process, and how to the initial last product. Next, please. And here we have used this packaging, use the infrastructure of State Agriculture Department, Government of Assam. And the shelf life of this canned pineapple is about 12 months. But I have tested after 12 months also, 1.5 years, it is very fresh in nature. And the nutrition value is also very high in these canned fruits. This is 8 to 10% sugar, the TSS only, total soluble sugar, vitamin A and C, minerals like calcium, magnesium, phosphorus, and iron, and mainly digestive enzyme bromelain. Next, please. So, innovative and science and technology component. And technical support. Technical support mainly I have taken from Horticulture Research Station, Assam Agricultural University, and Guwahati University, and Indian Institute of Entrepreneurship, Guwahati, for marketing purposes. Then these women self-help groups are very interested to attach themselves with us, because this is a new initiative for cultivation of pineapple plants and their value-added products. Then mainly the trainings, attending the trainings, the village women who are engaged only in household works, they are very much interested for tissue culture, cultivate to tissue culture pineapple plants in their backyard garden. In this connection, I have also informed that mainly in our region, the commercial cultivation is not yet established. Generally, they are cultivate in these pineapple plants in their backyard garden only. But nowadays, after training and training of the women self-help group, there are some of the women groups and some of the nursery men, mainly Sundarban Nursery of Gwalpara district. They are very keen interest for rearing of tissue culture plants in their nursery. They take up as a they want to take up the as a commercial scale. And next, please. Next, please. The trained women of self-help groups were motivated and their skills were developed in hardening of tissue cultured pineapple plants, which will help them to establish their own nursery. In this regard, I am informed that Mrs. Rumila Kolita of Mrs. Apna Deka of Milijuli Atma Nirbhar Group is one to look after the tissue cultured pineapple plants by using the facilities available in the society up to the stage of marketing as potted plants. And after rearing some days, they are selling their products as a potted plants. Then Mrs. Apna Deka of Milijuli Atma Nirbhar Group wants to look after the tissue cultured pineapple plant, and they already developed a small nursery in their backyard garden. Then one of the Atma Nirbhar Group led by Mrs. Anjali Sharma is planning to produce the pineapple slice packed in sugar syrup only under sterilization condition. And they are now, she is now started to produce. Then some of the women also earn by selling fresh fruits from their own field, as well as by selling of value-added products like fresh juice, then canned fruit, jam, jelly, etc. So I think they will Atma Nirbhar, or after in the long run they will Atma Nirbhar, and they earn some economic benefits. Then some of the major constraint is the small land area of farmers, and the infrastructure for grading and standardization is not available. Then poor storage facility and intercropping of other crops with pineapple is neglected in the area. So but some other aspects also, some pineapple cultivation. The main one is maybe fiber extraction from pineapple leaf and fortified to make cloths, ropes, etc. Then extracts of enzyme, bromelain, then pineapple, other processing foods like pineapple candy, and also after harvesting the leaves of the crown, it can be used for mulching purposes as they get more times to decompose. So this is the nutshell of my work. Thank you. This work is supported and catalyzed by Seed Division of DST, Government of India, and highly acknowledged. Thank you,
ma'am. Thank you, ma'am, for informing us about the processing of pineapples and their value addition, and also highlighting some of the challenges in processing. Now we move on to the next speaker, Yes. Major post-harvest problems farm to machine by Mr. Jyoti Sarup, Unnati Cooperative Marketing Cum Processing Society, Talwara. I invite Mr. Jyoti Sarup to make his views.
I'm audible.
Yes, you are. Can you make your video on, sir?
It is on, ma'am. On my side, it is on.
Oh, okay, carry on. Fine. We are unable to see you. Yeah, it's fine now. Now, yes, you are visible.
Okay.
Yes, you can.
Thank you very much. Good afternoon to all. सभी को मेरा नमस्कार. मेरा नाम ज्योति स्वरूप है और मैं एक छोटी सी कोऑपरेटिव सोसाइटी है हमारी, जो कि हम लोगों ने स्टेब्लिश की थी इन 2003 with the support from Punjab State Council for Science and Technology. हमारा जो उन्नति कोऑपरेटिव का एक्सपीरियंस है, हम लोग बड़ा ग्रास रूट लेवल पे काम करते हैं. वी आर सिचुएटेड इन लोअर शिवालिक हिल एरिया ऑफ पंजाब, और जिसमें हम लोगों ने छोटी छोटी इंटरवेंशन के साथ लोकल कम्युनिटी लाइवलीहुड जनरेशन किया है फ्रॉम लोकल बायर सोर्सेज, जैसे आंवला, एलोवेरा, गलोए, बहुत सारी हर्ब्स जो हमारे फॉरेस्ट एरिया में ग्रो करती थी, उनको यूटिलाइज करके हम लोगों ने कुछ वैल्यू एडेड प्रोडक्ट्स बनाए. एंड आई एम हैप्पी टू शेयर के बहुत सारे हमारे बनाए हुए प्रोडक्ट अच्छे अच्छे ब्रांड्स में आज सेल हो रहे हैं, इधर जैसे डाबर और जैसे अपोलो फार्मेसी, मेड प्लस फार्मेसी. तो बहुत सारी जगह पे आप उन्नति की प्रेजेंस देखोगे अगर आप मैन्युफैक्चरिंग एड्रेस के लेवल पे जाओगे. तो आज जो मुझे बोलना है कि पोस्ट हार्वेस्ट प्रॉब्लम्स, तो इसमें मेरा जो फोकस है मेनली हम लोगों को, जो हम ग्राउंड पे काम करते हैं तो बहुत सारे चैलेंजेस आते हैं. पोस्ट हार्वेस्ट मैनेजमेंट बहुत बड़ा रोल प्ले करती है. हम लोग फॉरेस्ट से कलेक्शंस करते हैं, अदर रॉ मटेरियल्स कल्टीवेटेड सोर्स से कलेक्ट होते हैं, तो उनमें बहुत सारी प्रॉब्लम्स आती हैं. तो मैंने कुछ प्रॉब्लम्स को लिस्ट करने की कोशिश की है, और साथ में मैंने प्रेजेंटेशन में ये बताने की कोशिश की है कि कैसे एक छोटी सी इंटरवेंशन जो है वो बहुत बड़ा चेंज लेके आ सकती है. उसमें मैंने एक जैगरी की एग्जांपल ली है जिसके बारे में मैं बात करूंगा, और बाकी मैं जो बात करूंगा 2 क्रॉप्स के बारे में बात करूंगा जिसमें हमें अगर साइंटिफिक इंटरवेंशंस अच्छे ढंग से मिल जाए तो उसमें हम लोग प्रोसेसिंग लेवल पे बहुत बड़े लेवल पे जा सकते हैं, और फार्मर इनकम डबल करने का जो आत्मनिर्भर भारत में हमारा सपना है तो वो अच्छे ढंग से पूरा हो सकता है. तो नेक्स्ट स्लाइड प्लीज. नेक्स्ट स्लाइड प्लीज. तो ये कुछ 2 स्लाइड्स मैंने IIHR की एक रिपोर्ट से ली हैं कि कितने पोस्ट हार्वेस्ट लॉसेस जो है वो हम लोग वेरियस क्रॉप्स के अंदर जो है वो बियर कर रहे हैं. ये डाटा आई थिंक इजीली नेट पे जहाँ बाकी जगह पे अवेलेबल है, तो मेरा बहुत ज्यादा इस डाटा पे बोलने वाला नहीं हूँ मैं. तो जस्ट जिससे प्रेजेंटेशन के कैसे हम लोग अच्छी क्रॉप्स जो हैं उनको लूज कर रहे हैं एट वेरियस लेवल्स, को भी हार्वेस्टिंग लेवल पे, कलेक्शन, सॉर्टिंग, ग्रेडिंग, पैकेजिंग. तो ये IIHR ने बहुत अच्छे ढंग से उसे डॉक्यूमेंट किया है कि कैसे कैसे हम लोग पोस्ट हार्वेस्ट लॉसेस एट वेरियस लेवल्स बियर कर रहे हैं. नेक्स्ट स्लाइड प्लीज. नेक्स्ट स्लाइड प्लीज. इसमें मैंने एक टोमेटो को हाईलाइट किया है कि कैसे जो टोमेटो है हम लोगों ने इसके ऊपर काम करना शुरू किया था. तो हम लोग फार्म लेवल पे ही अराउंड 10% हम फार्म लेवल पे ही लूज कर जाते हैं एट दिस डाटा, बट ओवरऑल जो लॉसेस है और बहुत कम जो है वो प्रोसेसिंग में जा पाता है. आगे स्लाइड्स में इसके बारे में मैं और भी बात करूंगा. नेक्स्ट स्लाइड प्लीज. नेक्स्ट प्लीज. I'm audible? Hello.
Yes, you are. Yes, you are.
Yeah. Just move to the next slide, please.
Yeah.
Yeah. So these are the various crops in which we are dealing, and we are facing various kinds of problem. Amla is one of the major crop we are collecting even from the local forest and even from the cultivated source. तो सबसे बड़ा जो आंवला में हमें प्रॉब्लम आता है कि प्रॉपर हार्वेस्टिंग अवेलेबल नहीं है. आंवला की कलेक्शन जब भी होती है तो वो बस लोकल फार्मर जो है वो डंडा लेके ट्री से वो आंवले को गिराता है, और व्हेन एवर द फ्रूट फॉल्स डाउन, तो जैसे ही उसको थोड़ा सा अभी चोट लगती है तो निक्रोसिस स्टार्ट हो जाती है. तो व्हेन फ्रूट अराइव्स एट द प्रोसेसिंग यूनिट, तो वो निक्रोसिस के साथ फ्रूट मिलता है हमें. तो दिस इज मेनली फॉर द प्रोसेस ग्रेड आंवला. जिस आंवला को रिटेल मार्केट में भेजा जाता है उसको हाथ से तोड़ा जाता है, बट प्रोसेसिंग के लिए कोई भी हार्वेस्टिंग टेक्नोलॉजी ना होने की वजह से जो आंवला है वो डंडे से झाड़ के लाया जाता है, जिसकी वजह से उसमें बहुत बुरी तरह से निक्रोसिस हो जाती है. और रॉटन ज्यादातर अगर आप बड़ी बड़ी जो मंडीज हैं आंवला की, उनकी बात करो तो वहां पे एक टर्म चलती है रॉटन को राटन बोलते हैं. तो दे यूज कि राटन आंवला का क्या रेट है और दूसरे आंवला का क्या रेट है. तो वो जो राटन का मतलब रॉटन जो रॉटनिंग हो रही है, दिस इज जस्ट बिकॉज ऑफ द हार्वेस्टिंग प्रॉब्लम इन आंवला, और उसकी वजह से फार्मर का भी और प्रोसेसर का भी बहुत बड़ा लॉस हो रहा है. उसकी न्यूट्रिशन वैल्यू, मेडिसिनल वैल्यू प्रॉपरली प्रोसेसर के पास पहुंच नहीं रही है. और जो इसकी प्रोसेसिंग के लिए ट्रांसपोर्टेशन होती है, जो तो हम लोग नियर बाई एरिया से कलेक्शन करते हैं, तो इट इज इजी, तो वो अच्छी कलेक्शन हो जाती है. बट व्हेन एवर आंवला मूव फ्रॉम से राजस्थान, यूपी और इवन सदर्न पार्ट ऑफ इंडिया, तो उस टाइम पे जो आंवला की पैकेजिंग और जो ट्रांसपोर्टेशन है वो उसमें पैकेजिंग इतनी पुअर होती है कि जिसकी वजह से बहुत सारी अगेन डैमेज टू द फ्रूट जो है वो होता है. तो देयर इज अ नीड फॉर साइंटिफिक इंटरवेंशन टू पोस्ट हार्वेस्ट मैनेजमेंट ऑफ आंवला फ्रूट, स्पेशली फॉर द प्रोसेसिंग इंडस्ट्री, जिससे कि प्रोसेसिंग इंडस्ट्री को सही क्वालिटी ऑफ रॉ मटेरियल जो है मिल सके, सो दैट कि हम लोग आगे जो है अच्छा प्रोडक्ट बना सकें इससे. एंड द अदर वन इज टर्मरिक. टर्मरिक में बेसिकली जहाँ पे तो लोकलाइज्ड एरियाज हैं, जैसे सेलम जैसे एरिया या नॉर्थ ईस्ट, जहाँ पे तो इसकी वैल्यू चेन प्रॉपरली एग्जिस्ट करती है, वहाँ पे तो टर्मरिक प्रॉपर वे में हार्वेस्ट होके अच्छे ढंग से मिल जाती है. बट जहाँ पे स्कैटर्ड कल्टीवेशन है, वहाँ पे फार्मर लगाने के बाद उसकी प्रॉपर ट्रेनिंग नहीं होती, उसको हैंडल करने के लिए कौन सी वैरायटी लगानी है, प्रोसेसर को कौन सी वैरायटी. प्रोसेसर इज मेनली कंसर्न अबाउट द कर्क्यूमिन कंटेंट, and the farmer will put the spice grade turmeric. तो वो जो गैप है वैल्यू चेन के अंदर, सप्लाई कहाँ देनी है, प्रोसेसर को कुछ चाहिए, फार्मर कुछ ग्रो करके कुछ बेचना चाह रहा है, तो दैट काइंड ऑफ faulty value chain is there in turmeric. Similarly, अश्वगंधा जब से ये लॉकडाउन हुआ तो ये इन चीजों की डिमांड जो है ना वो मल्टीफोल्ड हो गई है, और मल्टीफोल्ड होने के बाद इसके अंदर इन चीजों के अंदर बहुत बड़ी अपॉर्चुनिटीज आ रही हैं. तो वो अपॉर्चुनिटीज को कैश करने के लिए पोस्ट हार्वेस्ट मैनेजमेंट ऑफ दिस क्रॉप इज नीड ऑफ द आवर. और इसमें इसकी भी हार्वेस्टिंग प्रॉब्लम और जो ग्रेड्स के हिसाब से मटेरियल आना चाहिए ना, वो प्रॉपरली आता नहीं है. और इन द मार्केट लैंग्वेज यूजली से कि कोई बात नहीं, ये प्रोडक्ट बनाना है तो कचरे वाला अश्वगंधा ले लो, ग्रेड ए बी जो है वो तो एक्सपोर्ट के लिए चला जाएगा, तो आप यहाँ पे कचरे वाला अश्वगंधा ले लो. तो वो जो कचरे वाला अश्वगंधा मतलब कि इससे मिक्स्ड काइंड ऑफ क्रॉप, जिसमें हम लोगों को ना तो विथेनॉइड्स कंटेंट मिलते हैं, ना ही कुछ एक्टिव इंग्रेडिएंट्स अच्छे मिलते हैं, और ना ही वो प्रोडक्ट में हम लोग इफेक्टिवनेस क्रिएट कर पाते हैं अपनी में. तो जस्ट तुलसी ह्यूज डिमांड, बट द प्रॉब्लम इज जहाँ पे कल्टीवेशन हो जाए तो लार्ज स्केल ड्राइंग जो है ना It is not possible. We even tried in solar dryers. हमें PAU ने आपके DST के प्रोजेक्ट के अंदर ही एक सोलर ड्रायर्स फोर्स्ड एयर सर्कुलेशन ड्रायर लगा के दिए थे हम लोगों को यहाँ पे. तो वी ट्राइड, बट उससे इतनी छोटी क्वांटिटी सूखती है, इतनी छोटी क्वांटिटी है कि जो आउटपुट एट द फार्म लेवल जो है वो बहुत कम आ रही है. तो देयर शुड बी सम टेक्नोलॉजी जिससे हम लोग फार्म लेवल पे लार्ज स्केल ड्राइंग कर सकते हैं, क्योंकि ये लीव्स हैं, लीव्स को ड्राई करना इतना मुश्किल नहीं है. बट अभी जो ड्राइंग होके आ रही है वो इतनी मतलब गलत ढंग से, इतनी अनऑर्गेनाइज्ड वे से ड्राइंग होती है कि हमारे पास जो मटेरियल पहुंचता है वो बुरी तरह से ऑक्सीडाइज्ड और ब्लैक कलर के रूप में हमारे पास मटेरियल पहुंचता है. जो हम लोग खुद करते हैं उतना मटेरियल तो सही रहता है, बट जब हम हेलो या एंड similarly aloe vera
Sir,
yeah.
Can you come to your initiatives, Unnati's initiatives, and the interventions that you have made to resolve these problems? I'm requesting you to expedite it, sir.
Yes, just go to the next slide. Similar is the problem with various, these are the basically problems we are facing in the procurement of various kind of post-harvest problems in the various kind of raw materials. Yeah, I just want to add this the problem of this is two case studies I have taken. The aloe vera. Aloe vera, what we are procuring, उसमें हम लोगों को बहुत सारे losses bear करने पड़ते हैं. बिकॉज जो फार्म उससे हाईली पेरिशेबल क्रॉप है, जो फार्म से प्रोसेसिंग लेवल पे फैक्ट्री तक पहुंचता है, तो बहुत इसमें डिस्टेंस ज़्यादा होने की वजह से समटाइम्स एलोवेरा लीव्स कम्स फ्रॉम राजस्थान, चाहे हम प्रोसेस कर रहे हैं, चाहे पतंजलि प्रोसेस कर रहा है, कोई और भी आयुर्वेदिक यूनिट कर रहा है, तो लीव्स ऑलवेज कम्स फ्रॉम मोस्टली फ्रॉम राजस्थान. तो जो फैक्ट्री और प्रोसेसर का गैप इतना
You are not audible, sir. Mr. Saru?
No, it is audible.
Now it is. In between, we missed your word.
So where I missed in the aloe vera, I missed it.
Continue. No, you go ahead. You proceed, sir.
Yeah. So the problem in the aloe vera, I was telling, whether we process it or Patanjali process it or any other big Ayurvedic company process it, the main raw materials come usually from the Rajasthan. तो उसमें प्रॉब्लम ये रहती है कि फैक्ट्री और फार्म का डिस्टेंस इतना ज़्यादा रहता है कि ट्रांसपोर्टेशन लॉसेस बहुत ज़्यादा होते हैं. तो जो अभी फार्मर को बियर करने पड़ रहे हैं, वो प्रोसेसर कोई भी बियर अभी नहीं कर रहा. तो वी नीड ए साइंटिफिक इंटरवेंशन के कैसे हम लोग फार्म लेवल पे कोई प्रोसेसिंग टेक्नोलॉजी डिवाइस कर सकते हैं. सो supply to the major secondary processor. Next slide, please. Similar is the tomato processing. Tomato का सीजन बड़ा शॉर्ट सा है, तो what we tried कि अगर फार्म लेवल पे प्राइमरी प्रोसेसिंग होके टमाटो जो है वो बड़े टमाटो यूनिट्स को मिल जाए, तो we can make huge quantity of tomato paste. तो we need a टेक्नोलॉजी और मोबाइल प्रोसेसिंग यूनिट, जैसे वीट के केस में कार्बाइन आता है किसान के खेत में, उसका वीट निकालता है और उसको हैंड ओवर करके चला जाता है. तो सिमिलर काइंड ऑफ टेक्नोलॉजी इज डेवलप्ड इन टोमेटो प्रोसेसिंग. तो टोमेटो पेस्ट का वी हैव द वेरी गुड सेप्टिक फैसिलिटीज इन आवर सराउंडिंग एस्टेब्लिश्ड बाय पंजाब गवर्नमेंट. तो टोमेटो के फार्मर्स हर साल सफर करते हैं, हर साल वो जो है मतलब टोमेटो जो है रोड्स पे आ जाता है. तो इफ दिस काइंड ऑफ टेक्निकल इंटरवेंशन इज प्रोवाइडेड बाय अ साइंटिफिक इंस्टीट्यूशन, तो वी कैन डू वेरी गुड बिजनेस इन टोमेटो प्रोसेसिंग. नेक्स्ट स्लाइड प्लीज. So these are some of the just quotation from various newspapers and news agencies. Okay, what we are losing in the size of the wellness market, the annual raw materials. Just scroll on the next slide, please. Next, please. Yeah, just this is just for the information sake. Just go to initiatives of Unnati. So we have basically we have the number of initiatives, whatever we are earning in Unnati. Unnati is a total self-sustainable project, जिसमें हम लोगों ने जो DBT की ग्रांट से एस्टेब्लिश हुआ था in 2004 with the help of Punjab State Council for Science and Technology, with the objective to generate livelihood of the local community utilizing the local resources. And 2007 में ये प्रोजेक्ट पीरियड ओवर हो गया था. From 2007 to till date ये प्रोजेक्ट सेल्फ सस्टेनेबल मोड में चल रहा है. After that we never took even a single penny from the government or even a single penny from any bank. तो few lakhs की टर्नओवर से this year we will be around 50 crores per annum. और ये सारे का सारा जो है वो अराउंड हमारे 990 कलेक्टर्स हैं एट द बैक एंड, जो वेरियस हब्स और रॉ मटेरियल्स की कलेक्शंस करते हैं. यहाँ पे प्रोसेसिंग होती है और प्रोसेसिंग होके टू वेरियस कंपनीज वी आर सर्विंग अंडर वाइट लेबल. और जितना भी हमारा प्रॉफिट आता है इट इज फ्लो बैक अंडर द कोऑपरेटिव मॉडल, इट इज फ्लो बैक टू वेरियस मिशन. तो इसमें ये अलग अलग तरह के मिशन जो है वो मैंने मेंशन किए हैं. इसमें से बिकॉज ऑफ द लेस टाइम आई हैव चोजन ओनली वन मिशन टू एक्सप्लेन. नेक्स्ट स्लाइड प्लीज. हम लोग अभी अपने इस मिशन के थ्रू वी आर जनरेटिंग अराउंड 5 करोड़ टू आवर कम्युनिटी पर एनम फ्रॉम द रिसोर्सेज जो जंगल में गिर के वेस्ट चले जाते थे. तो जैगरी इनिशिएटिव वी हैव स्टार्टेड इन 2014. तो ऑब्जेक्टिव यह था कि जैगरी हमारी ट्रेडिशनल क्रॉप है और ट्रेडिशनल प्रोडक्ट है जो कि बहुत ही अच्छी न्यूट्रिशन वैल्यू होल्ड करती है. तो हाउ वी कैन improve its quality. So because Unnati is a group of some scientists, I'm also from the biotechnology field and we have various kind of scientific people in our group. तो जब हम लोगों ने गुड़ को अच्छी तरह से स्टडी किया, इसकी पूरी वैल्यू चेन को स्टडी किया, तो हम लोगों ने फिर इसके लिए वी अप्रोच्ड वेरियस इंस्टीट्यूशन लाइक इंडियन इंस्टीट्यूट ऑफ शुगर केन रिसर्च, पंजाब एग्रीकल्चर यूनिवर्सिटी. तो कहीं पे बहुत ज़्यादा हमें टेक्निकल इंटरवेंशन जो थी वो नहीं मिली. देन वी स्टार्ट वर्किंग आवरसेल्फ और हम लोगों ने जैगरी हार्वेस्टिंग से, शुगर केन हार्वेस्टिंग से लेके जैगरी बनाने तक की पूरी प्रोसेस को साइंटिफिकली कैलिब्रेट किया इन जस्ट ए पीरियड ऑफ अराउंड 3 years. तो अभी हम लोगों की इंटरवेंशन से ये है कि जो फार्मर्स हमारे लिए जैगरी बनाते हैं उनके सबके पास 2 इंस्ट्रूमेंट्स रहते हैं, रिफ्रैक्टोमीटर एंड पीएच मीटर. तो इन द फील्ड ये दे कैन सी के कौन से गन्ने का गुड़ बनेगा, कौन से गन्ने का गुड़ नहीं बनेगा, कि उसकी स्पेसिफिकेशन हमने रॉ मटेरियल की फ्रीज की कि गन्ने का गुड़ बनाने के लिए ये आपको पीएच लेवल चाहिए शुगर केन जूस का, और ये आपको जो है इसका टीएसएस चाहिए जो रिफ्रैक्टोमीटर से. एंड आफ्टर दैट इन प्रोसेसिंग ऑफ जैगरी we used instead of using hydro or sodium bicarbonate or other kind of chemicals, we utilize Sukhlai with the help of Indian Institute of Sugarcane Research. उनसे जो भी knowledge exchange हुआ हमारा, तो we choose this Sukhlai as a clarificant. तो उससे we were able to remove delete the use of this hydro and other chemicals, and even we this okra seed powder also we use for the clarification, but Sukhlai was easily available in our local area. That's why our most of the farmers are using this Sukhlai. And the marketing जब initially हम लोगों ने start किया तो major hurdle was कि अच्छे गुड़ का कोई ग्राहक नहीं था because अच्छे गुड़ की कीमत ज्यादा है. So we took the initiative of marketing of jaggery also along with the Markfed Punjab, because Markfed is our federation cooperative. So Markfed has started the marketing of jaggery, as well as we have also started with various companies, and you can get our made jaggery, Unnati made jaggery in Apollo Pharmacy, and even at the good stores you can get our farmers made jaggery. So farmer jaggery is made by the farmers, it is packed in our unit, that's all. And जो जैगरी पे हम लोगों ने जब काम करना शुरू किया था, तो तब जो हमारा विजन था कि हमने क्यों काम करना शुरू किया था, बिकॉज वी वांट टू रिप्लेस पिल्स विद द जैगरी क्यूब्स. तो हम लोगों ने वेरियस काइंड ऑफ जैगरी क्यूब्स बनाए, जिसमें हम वी ट्राई टू फोर्टिफाई इट विद हर्ब्स, एंड द अदर ऑब्जेक्टिव हमने शुरू इसलिए किया था कि हम लोग आयरन फोर्टिफिकेशन जैगरी के अंदर करेंगे कि 50% of the RD iron if we are able to deliver through jaggery in the 10 gram cubes. तो उसके लिए we need some scientific intervention कि कोई हमारे लिए काम करे, but किसी ने जो है अभी हमें इसके लिए कोई सपोर्ट नहीं मिली है. कोई we have written to NIN and various departments कि आप इसमें अगर जैगरी को फूड मैट्रिक्स बना के इसकी फोर्टिफिकेशन कि कोई भी न्यूट्रिएंट डिलीवर करना है तो मैट्रिक्स कैन बी ए जैगरी. तो अभी इसके ऊपर अभी इफ एनी साइंटिफिक बॉडी कैन प्रोवाइड द इंटरवेंशन, तो वी आर रेडी टू वर्क विद देम. इसी तरह से वी हैव द वेरियस मिशन. वी आर वर्किंग ऑन बैम्बू, वी आर वर्किंग on the seed ball technology under our green mission, with which our self-help groups are making seed balls, and we are selling those seed balls to some companies under their CSR activities. So these kind of work we are doing, and the major theme of this project is women empowerment. And even you come to the processing unit of the society, so you will find 80% of the work staff is a woman, and even in the back end also most of the collection is done by the male workers, the male collectors, but the sorting, grading, and the transportation, before transportation, is done by the women. So this is something about the Unnati. Next slide, please. So these are some of the jaggery experiments we have done. We made jaggery with boiler-based units. We made jaggery with traditional units. We have tried number of things, and I'm also happy to share before jaggery. Our knowledge was transferred to Punjab Agriculture University in technology, and based on that knowledge, Punjab Agriculture University has designed a training program and a literature for training of the local farmers, and around 200 plus farmers are trained by Punjab Agriculture University. Dr. Mahesh is there, who is training, and we are selling jaggery in these kind of tubes and different molding format. Thank you. So this is all about our organization. These are just the units we have developed. Thank you very much.
Thank you, Mr. Jyoti Sarup, making us aware about the technological interventions by Unnati to reduce post-harvest loss of perishable products which have short shelf-life. Thank you. And now our next expert is Mr. Vikas Jha, Rukar Technologies, Mumbai. He is going to present Sabji Cooler Bridging High Tech at the doorsteps of marginal farmers. May I request Mr. Vikas Jha to make the presentation? And
yes, ma'am. Thank you, ma'am. And good afternoon to everyone. May I request to play a small video I have shared with you all on the mail. So this is 1.5 minute video.
Okay, we'll run it, but actually we would not like to, we are going to upload it. Can I share something, sir? That video has a copyright of NDTV. So
okay.
It will be difficult for us
okay,
to
ma'am.
upload it.
No issue.
And
yeah.
Can you send us another one with revised one so that we can run it? We will.
Okay, I will share, definitely. I will share. So next slide, please. In the interest of time, RUCAT is funded by 3 IIT Bombay alumnus from Sitara. So we were in the course, find out some of the problem and trying to solve that problem. And then we found out that this is just not a one shot. We have to go for the marathon rather than a sprinter. And we founded the RUCART. And next slide, please. So you all are aware of that one, a small farmer, Indian agriculture is characterized by a small and marginal farmer. So I will not put up time here. Next slide, please. So yeah, so India has one of the lowest penetration of cold storage, and we found that, and we come down that these are the three main reasons. One is the cost intensive, solar and electricity driven 3 lakh plus per metric ton, 15 lakh for 5 metric ton. Most of these are designed for the long term storage, and then there is a stability issue. And so we came with these three issues. We're trying to come up with a new one called as the subject-cooler. Next slide, please. So this is the individual household or farmer farm-based storage facility where you can keep for this for about 4 to 5 days. And mostly for this short-term storage. Why? Because most of the marginal farmer just after harvest want to sell this produce so that he or she has the cash in hand. And next slide, please. So this is the subject cooler. This is the inside one. So this is the inner chamber, a mix of the GI tank, and outside center is a mix of the brick wall. In between these two, we fill up the nitrogen gas filled in the plastic cricket ball, and that is the in between these two walls. And then there are some other intervention like these carrots, which you are seeing, is especially designed for the maximum airflow and less fungus growth. So these pictures are from this Sundargarh district of Odisha. After May 24th, after this, once the second phase of lockdown was lifted, with the help of on the request of Collector Sundargarh, we were installing per day one subject cooler in Sundargarh district since May 24th to 30th of August. And this we have done with the help of our trained women. So we have RUCART has set up one women technology center in Tangarpalli block of Sundargarh, and we have trained them. So I was in Mumbai, RUCART team, most of the team member were in the Mumbai, and only one team member was allowed in to stay in Balisankara, in Sundargarh district. But with this 15 women training who was trained for the installation and capacity building of the farmers for this subject cooler, we were installing per day one subject cooler in Sundargarh district. So that is the here Atma Nirbhar Bharat come up. So you train the people, and they will do most of the time you are away from the location, focusing on your work. So you can, this is for the short time, as you can keep the leafy vegetable excellent life for 2 days. Losses will be lesser than the 5%. Other vegetables we can keep for 4 to 5 days. Losses will be less than 3%. And you can also keep fruits like watermelon, mango, banana, pineapple. So this we learn from the farmers that they are using this subject cooler as a natural ripening chamber. This is next slide, please. So these benefits are based on a study done by MS Swaminathan Foundation in Odisha. In Odisha, we have established more than 100 plus subject cooler, and across the India, we have around more than 200 plus subject cooler right now. And in this season, we are constructing again 100 plus subject cooler in Sundargarh district alone, 200 subject cooler in Marathwada region of Maharashtra. So this is all we are doing through the training. We train the women entrepreneurs for the installation, capacity building, and quality control. And RUCART give this training, design, and the materials. So this is a collaboration between a technological startups with the entrepreneur. And to help these subject cooler adopters to sell and get the maximum benefit, you are using IoT. So in each of the subject cooler, this is optional for the adopters. Once they adopt it, we put up a sensor. That sensors give 3 data. What is temperature inside? What is relative humidity inside? or how much produce have kept inside. That through this comes through the cloud computing, we are giving this access to FPO, CEO, or a women self-help group leading members, and they can see on their mobile key how much produce is stored in each of the sabji cooler. So if, in a 100 kg sabji cooler, if the store produce 50 kg plus, they can send their vehicle, collect from the farmer doorsteps, and then they can supply to the market. So this is the mechanism, so that farmers at their doorstep, they are able to sell their produce to the FPO or to the SHG, and SHG members are connected directly with this, please on this slide only, directly with the potential customer, and in the potential customer can see in their own mobile how much produce is available with each of this SHG or FPO or farmer, and they can directly give it to order to the SHG or FPO. So that is here the IoT combines with this technology, and we give the benefit to the farmers as well as the customers. So last slide, please. Eight number, not next, last one. 8 number slide. So what is the benefit of this? So earlier farmer used to harvest only one times in a week, before the weekly hard day, before this, the market days. After getting the sabji cooler, they are harvesting 3 times in a week. So it is almost sorted, graded. So that is why we are able to collect directly from the farmer's doorstep. Because if they are harvesting 3 times in a week, they are just harvesting the mature produce, not under mature, over mature. And so it looks like this is sorted and graded. With the help of this IoT and all, they are not only to connect to the individual customer, but also a small shopkeepers, vegetable shopkeepers in the block level or gram panchayat level or district level. What is the result? Most of them got at least 30% higher price than than what they used to get earlier. And in some location where there is in a single village 20-25 sabji coolers, like in Gajpati district, they are getting almost double of the price what they used to get earlier. So this is the one product. Come next slide, please. But Rukat is also dealing with not only one but basket of technology. Next slide, please. So it is about from the Tidal pump. We started with Tidal pump when we were a student at IIT. Then we come to drip mulch. Then there is a gel coon. Then there is a peak rakshak, which keeps nocturnal animal away from the field. And then there is a sabji cooler. So these all we come through after discussion with the farmers and getting their problem, and we try to solve the problem by getting a technology, and we route this technology through the women entrepreneur mostly. That is all. Thank you very much.
Thank you, Shri Vikas Jha. I think this has the scope of upscaling and large-scale dissemination. Now our next presentation is by Mr. Anurag Agarwal, New Lead Dynamics Technologies Private Limited, Delhi. Mr. Agarwal is going to speak on refrigeration systems powered by farm waste. Over to Mr. Agarwal.
Yeah, good afternoon, everybody. Yeah, I am Anurag Agarwal from New Leaf. So New Leaf has built up Green Chill, and this is a refrigeration system that is powered by any kind of waste on the farms. This system provides a cooling capacity of 11 kilowatts, that is about 3 refrigeration tons. It can run cold storages of about 20 metric ton storage. It can cool to -2 degrees centigrade. It can be used as a dryer. It can be used as a ripening chamber. It can be used as a cold storage. It can also power milk chillers. So it's a refrigeration system, and you can use it for any kind of cooling application, including air conditioning applications. Next slide, please. Yeah, we'll skip this slide because everybody has talked about it. The next slide, please. Yeah, so this slide shows how the Green Chill system works. So the green chill system is powered by any kind of biomass, includes husk, straw, biogas, waste wood, coconut shells, bamboo. So in some locations, we are even powering it with things like coconut trimmings. We are powering it with cow dung pellets. So any kind of waste that is available on the farms, green chill is able to use it and power refrigeration systems and provide appropriate cooling capacities. So it can cool to -2 degrees centigrade. It uses a refrigerant that has a zero global warming potential. Absolutely no effect on the environment. Like I said, you can cool rooms of storage sizes of 20 metric tons. You can control humidity. So whatever your produce requires, the humidity level that produce requires, you can control it. You can store produce from a couple of weeks to 6 months. Also, one of the presenters mentioned that there is a problem of drying. Like Mr. Jyoti Sarup of Unnati mentioned that there is a problem of drying, especially tulsa leaves. We have dried neem leaves, and the neem leaves. So green chill can dry at very low temperatures. We can dry at 30 degrees centigrade. And the leaves that we dry using green chill, you really cannot spot the difference between a dried leaf and a fresh leaf. So it absolutely preserves color and nutrition and all the values of the produce that you're trying to dry. Next slide, please. Yeah, so we can run cold storages of various sizes, 10 metric tons, 15 metric tons, 20 metric tons. And the loading capacity can vary from 3 metric per day to 5 metric tons per day. Yeah. Next slide, please. Yeah, also green chill is eligible for financing by any of the government or private sector banks. You can get project financing of 75%. It is eligible for 35% subsidy under the National Horticulture Mission Scheme and 50% subsidy in many states across the country. Next slide, please. Yeah, so again, green chill, the social alpha promoted by Tata Trust is one of the investors in green chill. Indigram Labs Foundation and ISAP is another investor of green chill. Next slide, please. Yeah, these are some of the examples of usage of green chill. So this is a farmer, Shamlal, located in Neemuch in Madhya Pradesh. And on his farm, you can see that he is storing marigold flowers. So if you store marigold flowers before the festive season, the pricing of these flowers the procurement prices could be about 8 rupees per kilogram. And you can get 60 rupees per kilogram. So if you start storing marigold flowers for 3 to 4 weeks before any festive season, you can really make bumper profits. Next slide, please. Okay, again, you can see marigold flowers being stored inside green chill. Next slide, please. Yeah, again, these are custard apple or sharifa stored in green chill. Again, custard apple is very difficult to store because it emits a lot of ethylene and it ripens up very, very quickly. So this is one very major requirement to be able to develop small, low-cost ethylene scrubbers. So this is one limitation if somebody can develop these scrubbers. And these scrubbers should be very simple to develop because they use potassium permanganate. So small, something like a desert cooler, a small customized desert cooler can be built. and the potassium permanganate can be recharged once a week or once in 2 weeks, and the concentration of potassium permanganate can be measured. So then it would be very easy for the farmers to use it for ripening or to prolong the life of whatever perishables they are storing inside the cold room. Yeah, next slide. These are lemon. So you can see we teach our farmers on how to store lemon, how to harvest lemon crops. So the lemon is harvested green. You have to apply a fungicide. Natural edible wax coatings have to be applied. So we train our farmers on how to harvest these and how to process these before they store it inside the cold rooms. So you can see our people are working with the farmers to help them train. Yeah, next slide, please. Yeah, and then these lemon can be stored inside the cold room. So generally the regions are Madhya Pradesh and Gujarat. And so you have the lemon harvest coming in January, in the first few weeks of January. And by the time you are in April, the price of lemon could change from 10 rupees per kilogram to 60 rupees per kilogram. So he could earn 6 times more by selling in retail, and in wholesale, and in retail the prices could change from 10 rupees a kilogram to about 100 rupees a kilogram in semi-retail. So by storing lemon for about 3 months, he could increase his earning by 6 to 10 times. Yeah, next slide, please. Yeah, so you can see peas being stored. So peas does not have a very long shelf life. You can see that the women are working on the farms and sorting out the peas to be able to store it inside green chill. So again, the benefit of storing peas is that you can aggregate. So if you're harvesting 1 ton a day, you can aggregate it for about 7 to 8 days, and you can have 1 truckload of peas that can be sold to a distant market. So it is you can have 10 tons of peas pre-cooled, and it can be shipped out to a distant market so that it does not get damaged on the way, and you can get higher pricing from a bigger mandi. Next slide, please. Yeah, so in Punjab, this is a cold storage storing kenu, and the last harvest of the kenu can be stored very conveniently for 2 to 3 months, and at the end of that, the pricing could really be 4 to 5 times as the original price. Next slide, please. Again, apple stored so this is again on the foothills of Punjab in Hoshiarpur. Apple can be stored, and again, when you store apple, you need ethylene scrubbers. So this small, low running cost ethylene scrubbers, I think, is a very, very major requirement. So if people can develop these scrubbers, it will be very convenient for use of these small cold rooms. So you have very expensive scrubbers which can be used inside large cold storages, but there is nothing available for these small cold storages, like 15 metric tons or 20 metric tons. Next slide, please. Again, capsicum. So again, during the lockdown, the capsicum was being sold at 2 rupees a kg, 3 rupees a kg. And by being able to store it in a cold storage, the farmers were actually, by storing it for 3 to 4 weeks in the cold storage, the farmers were actually at least able to recover their costs. Next slide, please. Yeah, so basically you can store onion but normally for onions, we have very, very large cold storages. For onions and potatoes, this is a temporary storage before it can be shipped out to a larger cold storage. Next slide, please. Yeah, these are watermelon and muskmelon. Again, in Punjab, there is a bumper harvest of melon and watermelon, and many times it is difficult to find markets for these crops. So they can be stored, they can be pre-cooled, and then they can be shipped out 1,000 kilometers away, and then they can arrive fresh. Yeah. Next slide, please. So green chill is also used for ripening. So we can ripen mangoes. You can see the uniform ripening of mangoes. So we use ethylene canisters inside these green chill cold rooms, and so normally the price of a green mango is about 20 rupees a kilogram. By ripening it, you can double the price to 40 rupees a kilogram. So within 4 to 5 days, so basically use 3 to 4 days of ripening, and this will allow the farmer access to local markets and get double the price by ripening it. Yeah, next slide, please. Yeah, so you can also ripen bananas. Again, bananas, green bananas sell for about 10 rupees a kilo. When you ripen it, you can double the price. You can double the market price. You can sell it for 20 rupees a kilo. And these small cold storages outside small cities can be used for ripening bananas, ripening papaya, ripening mangoes. So green tomatoes, one day before you want to sell it into the market, you can ripen them using ethylene scrubbers. So you can have a green tomato on one day, and the next day you see a market requirement for it. You can overnight redden these tomatoes, and without ripening them, having them hard so that they can move off the shelves very quickly. They can have a long shelf life and move off the shelves very quickly. Next slide, please. Yeah, so this is the organic potato being stored inside green chill. Organic potato is very difficult because you cannot apply chemicals for storage. So the farmers are able to store organic potatoes for 3 to 4 months and then get a good price for it. Yeah. Next slide, please. Yeah, that's about it. Thank you very much.
Thank you. Thank you, Shri Anurag Agrawalji. This is in true sense an example of waste to wealth sustainable technology aligned with one of the national missions, waste to wealth. So we have now concluded this session. So the panelists highlighted the cold storage capacity and refrigeration system that is required to prevent the over 30% wastage of fruits and vegetables and other perishables. We have also seen how refrigeration can be used during sorting, processing, packaging, storage, and transportation. Thank you all the panelists for being with us and sharing all your insights. Now the session is open for interaction and question answers. So I request Dr. Datta to chair the summing up session. Over to Dr. Datta.
Yeah, thank you, Dr. Kinkini. I think one thing what is coming into mind, like though there are very good examples that where at the local level, the non-governmental organizations as well as the startups have created very good post-harvest solutions. But I think there is still there is a lot of the capacity building needs to be done into these sectors, and also there are opportunities of working with the knowledge in organizations to improve the efficiency. So I think one of the examples of the improving efficiency, from the Barefoot College, Mr. Kiruva has shown. I think that's a good example. It's like, how the dryer technology can be improved through the new introductions of innovation. So I think whether we have any expert committee members here. Dr. Joshi, I think he has not joined today. He couldn't join. Do we see, we see here, whom do we see? On the right hand side, I see
Dr. Vipin is there.
Dr. Vipin Kumar is there, sir.
Dr. Vipin Kumar?
Yeah, I'm here actually. I'm here.
Yeah, Dr. Vipin Kumar, in these sectors, what is your, after these sessions, what is your view? I feel there are a lot of miles yet we have to go. Yeah.
Yeah, I was listening and, all the sessions were very informative. And as I said yesterday, today also I'll repeat on that we should involve large number of students and particularly the business, school students in, developing the business plans around these innovations. And I think we should also, support the rural technology students in different institutions and should do the hand-holding program for them. I also feel that when we are getting these presentations for scientists, it is, fine. But, for those people, in fact, in rural areas or, in semi-urban areas, if we could make the multimedia, kind of presentations like the Vigyan Prasar is making lots of small films, in fact, they are more impressive than, a simple kind of presentation. So it would appeal to those people, in fact. So then we should also target small groups, small group trainings, and for that we have to develop the content of those, training. So the technologies, how the technologies can be implemented, the possible fundings they can get from, because the funding is also one important, component. Training on regulatory issues and business plan development. And I again feel that more and more, business, institute students should go for the intensive program in technical institutes as well as the voluntary organizations. Then definitely, with that support, lots of innovations will go to the masses. So, lots of wonderful technology, whether it is rice husking technology or many other technology, what people have presented. So, I was thinking at that time that if it is available in nearby area, I can buy one. Might be lots of other people are thinking the same way. So, I feel that no one company can cater the need of large society or large country like India. I think this, these technologies should be given to large number of small units, and so that it could reach everywhere, and it should generate the employment opportunities for large number of people, living in the rural areas or semi-urban areas. Yeah. So that was my submission, sir.
Okay, I think like Dr. Anil Joshi couldn't join because of these, the internet problem. But what he said, that's basically what he conveyed just to me on phone. That the experience of the Unnati cooperatives, I think that type of an the experiences also at a system level, at a cooperative levels with the the scientists, like as there in the Unnati cooperative group that Jyoti ji told that the scientific people are working at the field level. So that type of the cooperative systems are required at this time. And also in terms of the green leaf technology, his question is that whether the cost involved in that and whether that can be customized or downscaled. And also the third point, what he has brought, that this we have seen in the last week also, that we have a lot of this type of the technology at the local level, but when we want to upscale the manufacturing, whether we have that the tool rooms available there or not. So I think probably Mr. Agarwal, you can respond to this in the query of the cost of the systems and the possibility of the downscaling of that system for a small amount of the storage, and what are the challenges and what are the opportunities for them, Mr. Agarwal? Is it left?
Yeah.
Yeah, Anuragji, yeah.
Yeah. Yeah, so basically, what we see is that, so for such technologies, you are correct. When we visit farmers and we discuss these technologies, we don't really have to sell these technologies or to convince farmers. It's the other way around, that the farmers try to convince us as to why they need these technologies and how they're going to benefit, what kind of business they're going to do with these things. So it is only a question of making these technologies available, finding out the right financing mechanisms. So basically so the problem is that anything that you do in renewable energy is, first of all, anything to do with renewable energy, these systems are very large, and by virtue of being very large, they are pretty expensive. And when you are starting something, you are starting with a small scale, you don't have economies of scale, and so your pricing is very high. So basically, small scale, high pricing, and with limited kind of financing available to farmers to buy these technologies, it takes a long time for these technologies to scale up. So if something can be created so that these technologies can be scaled up, so if certain schemes can be created so that these technologies can be agglomerated together and can be scaled up, and that will really benefit both the farmers and the technologies and the environment and the total infrastructure. So again, as far as green chill technology is concerned, today it is a 20 metric ton system. It can be scaled down to make it a 5 metric ton system also, and we are working on it to have a 50 metric ton system also.
Thank you, Mr. Agarwal. Actually, this is the problem what we have come, and though we know, that here it is getting highlighted that in this systemic gap, this is the gap where if Mr. Agarwal has told that the small scale productions at the high cost and how really can be upscaled. I see here Mr. Rubab Sood from FICCI. Rubab, are you here? Rubab?
Yeah, hello.
Yeah, are you here, Rubab? Because hello, Rubab?
Yeah, I can hear you.
Yeah, this is a problem. What is coming here? In a systemic gap in this Atma Nirbhar Bharat. Do you feel with the FICCI, whether you have an experience or we can work towards this? Do you have any comments on this?
Yeah, no, I think manufacturing is a huge problem for any organization, and especially if you don't have economics of scale, we cannot, get to that price point. In fact, in yesterday's presentation under Vivian Ashram, Fab Village had a concept where, they would set up Fab labs in all these organizations who can make use of these instruments. So I think that will be very crucial for all these civil society organizations to have access to these, state-of-the-art Fab labs, which will be very crucial for them to, get those scale approachable.
Okay.
So I want to add something. I want to add a very important point that I felt a lack for. Basically, what I feel is that the problem is incubation of these, the companies who work with farmers. So basically, when you look at, almost all incubation centers are in cities. We really don't have on the field farmer-based rural village incubation centers where such devices can be tested out in real life. So basically, the farmer producer organization could be an incubation center. They could be, so I think it is very, very important that a few farmer producer organizations be made incubation centers, for different kinds of produce, and we provide them with expertise so that all the entrepreneurs go to the fields, go to the farms, and try their product firsthand over there in real life, and not inside the workshops.
Yeah, that's a the very practical suggestions, Agarwalji. And I think in this context, what we are saying about that this incubation idea, the tool room idea, I would like to bring Dr. Ketaki Bharat from the PSA office. Dr. Bharat, this is a persistent problem, or the disease is in the system. What we can do?
Yeah, I completely agree with this. Rural incubator is required at the, but I think there our NGOs can play a part, Dr. Datta, and we need to reorient. Perhaps and those kind of a startups. Now this is Sabzi Cooler is from IIT Bombay. So like that, if we are able to showcase, as Dr. Vipin Kumar also very rightly said, through the film and using this virtual medium, can we get connections? Because nowadays people are also very proactive even at rural areas. So I think it is doable. Maybe we are having this transition state. All of us are learning phase also, and COVID also has allowed us to learn and expand our imaginations and creativity. So your suggestions and the concerns are very well taken, sir. And we need to work out the amicable solution with the DST's seed program, PSA office RUTAC program, and many other initiatives are taken. I think we will work it out. It is a very well said and important concern. Thank you.
Yeah, I think what we see here, that even yesterday what we've seen from the knowledge organizations, technology development and upscaling. Then today we have seen very good examples of the NGO scale the technology and upscaling, and not what we have heard about from the the startups and the manufacturers, that the problems of this upscaling. So this basically they converge some places. Now, what we are hearing about, this very good idea about the rural village incubation centers. I would like to, I have got some questions, but the questions are in the context of these sessions, and I find on the right-hand side of the chat box, many questions have already been answered. So I don't know, where I will take some of them, but I think many of them have already been answered by the concerned persons. But the most important thing that I just want to take it before our core support groups, because they are one of the most technology led non-governmental organizations nearer to the field. Maybe Dr. Yogesh Kulkarni or Dr. Maiti or anyone from the core support groups, if you can give this the response. We have talked about and what Ketaki ji has indicated, that in view of these changing situations and the focus towards Atma Nirbhar Bharat, whether the core support groups can evolve into this type of village incubation centers, looking into the strengthening the core part of the technological strengthenings of the core livelihood system in which they deal. My question is towards the experienced core support groups, and your response will help us in evolving together. So Yogesh ji, Dr. Yogesh Kulkarni or Dr. Maiti, like any one of you from the core support groups who are here, if you please can the response, or Dr. Lal Singh, anyone here. Dr. Maiti, yeah, please.
What we feel is that, yes, on one hand, during working with us, with the innovators, what we have found out is there is a strong gap between, one is the research part, and another, or research or the innovation part, and another is on the implementation or on the business part. So joining these two, what is truly, speaker, what he had also mentioned is the incubation one. Now, what we can, and incubation means not only the research part, taking the research into the field, but also understanding the business plan, also understanding the marketing. How do you take it into the field? So that part, I think that is what is lacking, and certainly we can provide some of the core groups. We can provide support to this, to take the initiative that has been just mentioned from the afternoon and to the field.
Thank you, Dr. Maiti, and I don't see Dr. Yogesh here. Dr. Lal Singh, if you can, do you have hello?
Hello.
Yogesh is there, sir.
Hello. Can you hear me? Can you hear me, Dr. Datta?
Yeah.
Dr. Datta, can you hear me?
Is it Dr. Lal Singh?
Yeah. Actually, this is one of the. Yes, yeah. This is one of the very valid suggestion for a rural kind of incubation centers, because I have been discussing it time and again, because until unless we test the technologies in the real sense, at the real beneficiary level, because we have a very different kind of concept. Until unless that kind of customization as per the requirement of the people is not there, actually nobody is going to take that technology. Most of the time what we have been doing is either we do most of the things of our interest and we try to impose those on the beneficiaries, and that is creating a lot of problems, because we have seen almost with our DST sport over 20 years now, we have many technologies which have reached to the people only because of this, because their kind of doubts were incorporated. We were incubated at IIT Mandi Technology Business Incubator for refinement of our solar technologies, but ultimately what is discussed there is not at all practically feasible, what we learned over there. Therefore, this is very important, starting a kind of intervention by the core groups for selected things. For example, if there are 20-25 people, everybody should work at least as example for incubating 1 or 2 technologies for the respective areas where they are working, and that will really give a big thrust to a program of the DST to develop something which can ultimately lead to the Atma Nirbhar kind of a Abhiyan progress. Thank you very much.
Thank you, Dr. Lal Singh. Dr. Yogesh, are you here? It's not there. Okay. So I think we can take the view of the other. I see Dr. Yogesh Samant and the other the other core support groups and the NGOs who are present here. If you want to give your view, please we are open to do it. But in the meantime, I will just see that some of the questions which has been raised during these sessions, I think whether we can check it or whether they have been answered or not. If they have been answered, then I think there is a questions of about drying vegetable temperature required 60 degrees, and can we have this much from solar dryer? I think this was directed towards the Mr. Kiruva of the Barefoot College. And I think he has already answered to it. Mr. Kiruba, are you here?
Yeah, I have answered it over private chat. I did not do it for
you have answered.
Yes.
I see here. And also, and there is a question that the business model of this technology or machine, considering the production of rice, is not continuous throughout the year. I think here also Dr. Gosavi has already, I think Mrs. Gosavi has answered to this to Dr. Maiti. So I see it here. Then there is an important question which has been raised is, what is the process of certification of post-harvest equipment? We have developed ground de-husking equipment, machines, and want to get certifications. I think this is like a big systemic gap, because you see everyone is many people have developed local solutions, but how really the standardizations should be done? This we have to we have already taken it up, and in one of the sessions we'll address this in our sessions as we go forward. This the standardizations of these things will be addressed. Then the machine of the composite machine, I think that is also Mrs. Gosavi has answered. Then there is a question for Mr. Kiruba that how much maximum increase in temperature and drying temperature we can get. This is also he has responded to. There's a question from Dr. Maiti that to reduce post-harvesting losses and distress selling, especially for the perishable goods, are you also looking at developing cold chain systems? Dr. Maiti, is it addressed towards Mr. Agarwal?
Yes, sir. What we were looking at is the cold chain systems, because that is what is happening in a lot of areas in the rural areas. Since the shelf life of the agriculture products like some fruits or other things is 7 days, 8 days, or 9 days, or even 14 days, like the lychees in Bihar, they perish within 7 days. So if any kind of a cold chain system which is suitable for small farmers, which can be adopted by a farmer or a cooperative of farmers, then they can set up, they can have a higher bargaining price if they can preserve it at least for a month. So that's the kind of question that I was looking at. Or
Mr. Agarwal, would you please respond to it, please?
Yeah, sure. Yeah, so as far as green chill is concerned, you can store 20 metric tons of produce, and depending upon the produce, you can store it for a month, 2 months, 3 months, even 6 months of time. And you can store it until you get the right market valuation, or until until there is a market demand for it. So yes, again, the benefit of using green chill is that the storage costs are very low, because you are using locally waste that is available on your farm, that you may burn and cause more pollution anyway. So it is both environmentally sustainable and allows the farmers to store for long periods of time at a very, very low running cost.
I would be in touch with you for the prices of this.
Yes, please, sure.
I think there is a very important, very interesting and important question is also there, and I would request any one of you can take it. That are there any work towards enhancing the nutraceuticals properties in the raw materials while processing? Because this is some sort of an fortifications, and I think this was discussed yesterday. So in the fortifications, increasing the nutraceutical properties in the fortifications, and yesterday's it is CFTRI presentation, it is there, and we will put it on the on our the portal. So please, you can consult there. So I think I see that that this post-harvesting, the technology is the is the requirement in order to this the farm to fork this loss reductions, and also to increase the efficiency in terms of the the economic value development. So I see here many of the other, the core support groups and other NGOs. Anyone can, raise the issues. And before that, I request Dr. Sharad Srivastava, from NVRI is here. Dr. Srivastava, what you have heard today in this context, the issues what we are discussing. Do you have anything? Do you feel that anything else can be added here, Dr. Srivastava? Dr. Sharad? I think he may not be there. Yeah, please say. Yeah, I see here, Dr. Joginder Walia, I see him, the many other, so any, this, your comment, please. Dr. Ramalakshmi Datta? Dr. Datta? See her name here. Dr. Ramalakshmi Datta?
Good evening.
Yeah, good evening. Good evening, Dr. Datta. Yeah.
Yeah.
So what we are discussing today, you have looked into in the context of the, the post-harvesting technology. And, there is a suggestions what has emerged that the core support groups could be, work as in basically rural business incubation center. Do you feel in the reality and the field situations, it will be a challenge or it will be the changed requirement?
Pardon, half of the question I couldn't listen properly. Can I once again listen to it?
What in this today's discussions, what you have heard from the NGOs and the startups, that in the context of the post-harvest technology, which is very important in the context of the agricultural production system, that there is an opportunity that the core support groups evolve into a local a rural business incubation center. My question is that from your experience, whether that will be a big challenge or it will be a new opportunity. And what is your view on that?
Yeah. I should say it is a big opportunity because there is a lot of scope of work that has to be done. And it's a big challenge too, because working at the grassroots, and we are trying to involve the farmers as well as the women groups, especially for different horticultural products and all. And if we get the help of such knowledge institutions and we are able to bring in these technologies at the grassroots, it's going to be of immense use and benefit to the people. And it's both a challenge as well as an opportunity. That's what I feel. And we need to take up few of the technologies on post-harvesting, food processing and all. It will be of help to the women groups who are working at the grassroots at a women technology park and all. Even this rice dehusking machine as they have developed, if it can be brought at the grassroots, it would be of much help.
Okay, thank you, Dr. Datta. There is a question for Mr. Jha, of the Sabji Cooler. Mr. Jha, if you are here, that for keeping vegetable fresh, we need 0 to 12 degrees centigrade temperature and humidity of 80 to 90%. Is this cool chamber suitable for above parameters? Mr. Vikas Jha? Mr. Vikas Jha, are you here? Left. That's the problem, like, you know. Or otherwise, this questions which is towards the Vikas, which is posed towards Mr. Vikas Jha, we will come back to you. And there is a question also that the cost of the cold storage machinery for preserving marigold flowers. Again, I think Anurag ji, like, you know, will it be possible for you to answer this?
Sure, definitely. So the ballpark figure for a 15 metric ton cold storage, green chill, and the cold room is approximately 12 to 13 lakhs.
Okay. So that's the initial investment one has to do, like, you know, for a 15 ton. But, you know, if you scale it down, like, you know, that it will it like how much the cost?
15 metric ton is really the optimal size, and if you scale it down, only the cost of the storage room goes down. So, you know, the cost really doesn't go down too much.
Okay. So I think overall, what we hear here, like, you know, from today, yesterday, and today, there are certain, you know, the systemic ideas and the recommendations has come, and I think the most important today is this: the rural or the village incubation centers, and we have we will work on it and we'll find it out, like, you know, how to take it there. And there is some suggestions for the, you know, technology agglomerations and the scaling up. So with this, if you have any comments on towards this, anyone you know, present here, it's welcome. Any one of you?
Dr. Sohan Pandya.
Yeah. Who is? I think we'll take one. You know, it is from Mr. Sohan Pandya from BEF.
No, Sohan Pandya from Center of Science for Villages, Bardha. He is working on the post-harvest technologies.
Okay. Sohan Pandya is here. Hello.
Yeah. Am I audible?
Yes, you're audible. Yeah, please.
All core support groups, they are wonderful incubation center as far as technology transfer is concerned. We have a history of transferring more than 45 technologies at a grassroots level. But all those things which we have passed, it needs a kind of a marketing. All my SHGs, they are saying that if there is a marketing provision, they will be able to produce, to process this agriculture produce, forest produce, and that is what is called as post-harvest processing, and will be able to market it. And some of them have done wonderful, and 3 of our SHGs have got Irkani Award of the Maharashtra state government. And it is done because forest produce which we have taught them under core support project, they are able to sell it in a good quantity in a different parts of Maharashtra. So if there is a help from any quarter as far as marketing is concerned, then the number of beneficiaries will shoot up like anything. It can be jaggery, or it can be even our post-harvest processed, it can be a machinery or all that. Small scale machinery, people are ready to process it, but then the processing cost is more than what is called, like you were saying, that bigger one, cold storages. Their capacity is big, so per kg the expenses reduces considerably. But if we make it a smaller version, then there is a problem of what is called the cost. The cost goes up a little bit, and then in market there is a what is called a problem as far as cost effectiveness is concerned. So in this particular case, so many technologies are there. We have done that, and here also from the forest and from the agriculture, we are able to process and sell X number of things. Thank you.
Okay. Dr. Anil Kumar, are you here from MSSRF? Dr. Anil Kumar? Or is it from, like, please, I'm saying that, why yes, that name is there. Is it from Yogesh Samant from where?
Yes, good evening, sir. I'm Yogesh Sawant from BAF. Can I speak a bit, few words?
Sure.
Yeah.
Sure.
Yeah. Thank you. Thank you, Dr. Datta, and thank you all at DST and all the presenters. Very good initiatives, and they have shared very great technologies that can be applicable for rural areas. We are basically working with farmers on various areas: livestock, agriculture, horticulture, natural resource management, and also promoting solar-based and other eco-friendly technologies. So through these initiatives, definitely many of them are applicable in most of our working areas. So just to mention a few that we would like to take it up on immediate basis, maybe initially on trial basis to standardize it to those particular locations, and then later on after standardizing them, we'll also be able to maybe scale up some of them that are very useful. So something like the paddy dehusker, like for the last few years, we have been involved in introducing small-scale paddy dehuskers at SHG levels. So to meet the requirements of interior tribal locations, wherein farmers had to travel to distant locations to get their paddy milled. So these paddy dehuskers are very useful at small hamlet level, which are giving employment to the SHGs as well as ensuring that at local level itself the service is available. So along with that, this particular paddy dehusker that was shared by Madam, that will also be useful because it has the added benefits of preserving the nutraceuticals. So we'll try and introduce this particular technology. We'll get in touch with them with Vigyan Ashram and introduce this. Second thing, like in many parts of the country, we have tried to introduce high value crop cultivation at tribal families, in tribal areas. So some of these are like vegetable cultivation. In some areas in Jawar, we have promoted small scale floriculture, which involves jasmine and marigold. So the cool chambers, which is the low cost option, as well as the biomass driven cool chamber, both we'll explore, and definitely we'll try to introduce wherever this is suitable and which works out very well. So thank you, thanks a lot, and also we'll try to explore other technologies that have been shared yesterday as well as today.
Okay, do you have anyone and any other comments here? If not, then we'll call it a day, and you will end. We'll end this, the sessions, and we will come back again on 28th and 29th with the agriculture and allied sectors, and where we will have, the animal husbandry, the poultry, the dairy, these sectors. So thank you all for joining with us, and we will take forward, these initiatives and this evolution process. Thank you for everything. Thank you.